There we go. That should have us going live. Hello, everybody. Welcome to Blue Marble. Just me and Mobius. But now going back to what we're talking about. Yes, when I was practicing up or trying to figure out how to do live streams, honestly, because I never had done one. That particular day, Bev had a stream going on, and I put out a little bit of it. Not much, for no reason really. And Bev
Oh,
got
I thought
very
it's happened.
and
I,
Bev got very upset with me for doing that. Um, and I've never done it again, and I wouldn't. But I see today he's planning on live streaming my YouTube live stream, exactly the thing he complained about. So if that's what he
no,
wants,
he didn't say he was planning on it. This is me asking you if that would be cool, but he said that he wouldn't be, probably wouldn't be able to. It would be pointless to ask you. And I told him, well, I just want to ask just so that I know, It had nothing to do with Bev. He wasn't asking me anything to do anything or ask you anything.
yeah,
That was
well,
all on me.
okay, yeah. He put an announcement up. That's all I know. That's what I saw. It came through uh, on my announcements.
Well,
But whatever. That's not a problem.
all right.
I'm okay with that.
So anyway, what did you want to talk about with LIGO? Like what specifically did you have anything particular or
Well, I think the way this started so long ago, Mobius.
yeah.
As I recall, you're the one that wanted to do the talking uh, about LIGO and uh, why I've been wrong about it.
Well,
And I was
what
hoping
do you
maybe you
think
could help me out here.
what do you think I'm saying you're wrong about? Because I don't remember ever saying that you're wrong about anything.
Well, I think I've shown, at least in one video, that the shape of the pads that the beam tubes sit on are not straight lines in free space.
All right, so let's
They're curved.
so I know. Um is in your opinion, or do you know if the tubes are straight?
Yeah, as far as I know, they are advertised as being perfectly straight.
All
Some
right.
of the straightest things we know of. Now, people exaggerate to a bit at times and say, "Oh, they're the straightest thing in the universe." Well, I never heard anybody actually say that, but they are and have been measured to be very straight. Yes.
And then so I assume your opinion is that the laser that's being used in LIGO is shooting straight, right?
Yeah, I don't think it has any choice because LIGO is operating at about a 10 to the minus ninth vacuum, so there's no atmosphere in there to cause any refraction.
And just for shits and giggles, does gravity have an effect on light in a vacuum?
Well, gravity has an effect on everything, but the gravitational field of the Earth is far too small to have any measurable effect on light.
So
You
you're
need
saying that
something
there
the
would be
mass
no
of the sun.
deviation. This is just the side point. I'm just asking questions. Are you saying that there would be no side or downward pull on a light in a vacuum over 4 kilometers?
Certainly nothing that I think we're capable of measuring. No.
Well, I mean, LIGO is supposed to be measuring to within like 1/50th of the width of a proton,
In the
or I'm
length.
sorry, 1/50,000th of the width of a proton, something ridiculous, right?
Yeah.
So
That's
you're
the
saying that device wouldn't be able to measure a deviation from straight from like with the effect of gravity on light in a vacuum?
well.
I
What
think
it's
their documents even say something about something like that, but whatever. Like I said, that's beside the point.
what it's measuring is the length of those tubes, right?
Mm,
Not the height of the beam. It's measuring the length of the tube
right.
and
And
changes.
the mirrors go back and forth to adjust. for the harmonics, right? The frequencies, to make sure that they're able to capture. And it's a complicated system. I mean,
Oh,
it's
very
pretty
complex.
complex.
Yeah,
Yeah.
very complex, and I don't pretend at all to be an expert on that interferometer. I understand the basics of it. It's a Michelson interferometer, period. You know,
Right.
but it's literally measuring a differential in the lengths of those two tubes, which are at right angles to each other. So any
So are you,
gravitational wave that comes through is going to affect one of them and not the other one in terms of its length.
but I mean, the thing does detect, like, or it's alleged that it detects, minute vibrations like miles away, right?
Oh, it's possible that it can, yeah, which is why they've got two of these things.
I mean, they say that it detects like a crow walking on the concrete uh,
Yeah,
enclosure.
I'm sure that's written down someplace or the other, Mobius. And it probably it would have the sensitivity to do a thing like that. But the reason they've got two LIGOs uh, and separated by a fair distance is so they can rule out these anomalies that are caused by, the truck going down the highway or the crow jumping up and down on the sidewalk or whatever.
Yeah.
Because now you're in a situation where you've got to have an equal crow jumping up and down in sync, at both locations, and that's pretty far fetched. So that's how they're able to sort out an actual gravitational wave from just noise that's inherent in any kind of measuring system.
Yeah. And I mean, you got to admit though that a broken clock is right twice a day. So
I've heard that.
it's not like it's unfounded or unheard of that things can happen simultaneously that would give the impression of something, right? Especially when you're looking so closely for that thing that you're detecting.
Yeah, that's true. Absolutely. True that all of those things probably should have to be considered, and I'm sure have been considered.
Yeah.
But
So
I'll
just
leave
so
that.
we're clear, like within this conversation, I'm not trying to debate you on what LIGO does or what it accomplishes or what it's meant for or anything like that. It's like my whole thing that I wanted to talk to you about is the geometry of the structure, the whatever. If it does what it says it does, great, whatever. But that's not what we're talking about. That's
Exactly.
not my okay. So like
Exactly.
all the technical stuff, and I mean it's interesting, but as far as like how many mirrors, they're pendulums, right? They're pendular mirrors.
Yeah, it's a fairly complicated pendulum arrangement. It's actually four pendulums in series.
Yeah, I'm quite aware.
Yeah.
Um, yeah, the quad as they refer to it.
Right.
Are
I'll
you
turn my
are
volume
you
up.
aware of the strands, the the fused silica strands that they use to support those things?
Oh yeah, that's amazing. That is amazing
And
stuff. Well, and
I
they
mean
do that. They do that because it's got a very favorable, very low coefficient of thermal expansion.
right, in the harmonics, it doesn't what do they call it, violin, like they
Yeah.
it doesn't
Yeah.
resonate.
Right.
Also, I mean, the tensile strength of that stuff is like extremely strong, but
Yeah.
the side strain of it, which any kind of like side to side motion, or if you were to angle, put any bending strain on those things, I mean they're super fragile. It's like a piece of glass, like
Well, it is
what
glass.
well, I know, but I mean it's a piece. Okay, it's a
Yeah.
piece of glass. It's thinner than like a half of a human hair or something like that, right?
Yeah. Yeah. And in certain directions, glass is extremely strong. If you keep it in tension, pure tension, or you keep it in pure compression, it's very strong. It
Right. So
does not
my
take. It
point,
doesn't take any shear load.
my question is, or my point, or whatever, my quandary is that these things are hanging. So tensile strength will be sufficient, but the side to side or any bending of that that silica glass, it's not gonna, hold up.
Right. Yeah, I doubt you could even touch one of those things without having it break.
Yeah. Well, I mean, I've seen documentaries and stuff where they do touch them, but it's not with any like strain on them. They're just kind of like uh loosely laid in somebody's hand just to show you the thinness of it, I
Yeah.
guess.
Yeah, I'm thinking about with a mirror actually hanging from four of
Yeah.
those strands. I wouldn't dare touch one of them.
Right.
If it's loaded, I would not touch it. I think you could cause it to fail very, very quickly. But again, all of that's quite interesting, but that's not what we're really talking about, right?
Well, I mean, the fact that it's a pendulum, I mean, you don't see that is problematic.
Uh, in terms of the shape of the machine, no, I don't. Why would it be?
Well, if over 4 kilometers, uh, and also the mid station that has mirrors where they have the fibro pero, I might be saying that wrong, the cavity where they bounce the laser back and forth before it returns to the source and then splits to the
Yeah, you're talking about all that stuff there at the vertex, right?
no, this is at the end of the arms. It bounces back and forth and then it comes back.
Oh, you're probably aware of details about this thing. I don't even know. I haven't studied all of that in any detail.
All right. Well, I mean, it's not just the splitter and 2 mirrors.
Oh, I know that.
A,
Yeah,
it's a
there's a lot of
complex system
equipment.
of a
There's
bunch of mirrors.
Yeah, there's a lot of mirrors and a lot of equipment inside that thing.
So over 4 kilometers, if there's 2 mirrors facing each other and they're on pendulums, bless you, and they're bouncing a laser back and forth between the two,
Mm-hmm.
there can't be any deflection, right?
Yeah, well, I have to say I don't know whether to agree or disagree with that because I'm not pretending to be an expert on that interferometer and all the inner workings of it.
Okay.
I'm interested strictly in the shape of that tube and the concrete pad it sits on.
Okay, but geometrically, like the mirrors would have to be perpendicular to that straight laser.
Yeah, they'd have to be perpendicular to the axis of that tube.
Okay. And then, so the tube itself, you said is straight. Now, the concrete pad, are you saying that the concrete pad is straight also?
Yes, in reality, the concrete pad is straight also.
So they don't have any adjusters on the sections of tube to lift it up or down or tilt it up or down?
Oh, are and were adjustments allowed for, so that they could calibrate it and force it to be perfectly straight. Oh yeah, that's
The
all
tube,
inclusive.
right?
Yeah, that's all inclusive in there. Sure.
All right, because the LIGO as builds that we've discussed before, that is the concrete slab, right? Not the tube itself.
That's the concrete slab, exactly.
All right.
Exactly.
And the tube can be adjusted up or down from that concrete slab.
Yeah, yeah,
Okay.
that would be possible, and I know where you're going with that.
Okay.
Yes, it would be possible that you could pour a level slab out there and put a straight tube on top of it, and then just take up the change with a bunch of adjusters. But that's not what they did. They built the concrete slab to be straight, not level.
Well, how do you know that?
Well, by looking at the elevation data. The elevation data shows it.
So when they poured the concrete,
Hmm.
like you've done construction before, right?
Yeah.
Like the steps involved and stuff. And I know Effie Dogma talks about his vast experience in construction and stuff too. But um, they they move dirt before they lay any concrete, right? Especially if it's got like tons of reinforcement steel in it,
Oh, yeah. Of course they do. Yeah.
right?
There's a whole lot of steps that you go through. Uh,
So when they were measuring out this area to be straight, what's your take on how they did it?
what on how they physically did that?
Like how they started, yeah, like the physical, like the guys on the ground, like the guys in the field doing the work.
Oh, there's a multitude of steps that they would have to go through. Quite
No, I mean
obviously.
like the first step. What do you think that was?
Well, the first step was to survey that site and find out where all the elevations are, the actual dirt that's there, undisturbed.
Right.
You have to start with that, and then set a uh, set an elevation benchmark that you're going to use, that you're going to work off of, and
Right.
um, and just go from there. It's a series of steps, all involving surveyors, right? Because they're going to have to give you grade elevations all along the length of that tube
So
as they work through the process of either cutting down the hills, which they did a lot of at Hanford, or building up areas, and that gets even more complicated because now you've got fill dirt, and you're going to have to take lots of steps to compact that properly
yeah,
so
I
that
mean
the stuff
I
doesn't
haven't
settle. You know.
admittedly I didn't do a whole lot of research on the Hanford facility because well frankly I heard or I read somewhere that they uh pretty much did a different method. They used a different method for establishing uh, their straight lines in the Louisiana facility versus the Hanford.
I'm not
But
sure. There were some differences in the way the two sites were handled. I think, but um,
there's
at the
also
end,
administration changes too during that whole thing. But whatever, that might be part of it. I don't
well,
know.
yeah, it went on for a long time, didn't it?
Yeah.
I mean, I think from the inception of it, which that's kind of a funny story. It was almost misleading the way they went about doing it. Uh,
So I mean, if they're not too terribly different, um, my research, I guess, was more based on the Louisiana facility. So if if you bring up the Hanford as far as like any kind of like specific differences, feel free. But I might not be as familiar.
well, I don't know if anything in terms of the end result is significant.
Yeah.
I think they did some different. I've seen reference to minor differences in the way they mounted the GPS antennas and stuff like that from one site to the other. Uh, but some of that was just going through the learning curve on whichever one they did first. I don't remember which one it was. One was in
Yeah.
front of the other one, you know. So when you learn something that it's going to work better, yeah, you're going to do differently at the other site. That
But
happens, but
both sites have the concrete slab, and then they've got the tube that
yep,
is adjustable on top of it, right?
yeah, right.
Okay. And so you're saying that the concrete is a straight line, and that's based on the as-built drawings.
Yeah, yeah, based on what the as-built show you.
So when they laid the concrete, how like from a horizontal reference, because like any, would you agree that any change in elevation from a horizontal reference would be a vertical change, like up or down.
Yeah, a change in elevation is a vertical change. That's by definition.
Okay, so if you're at, say, one location and you're looking horizontally to another location, any change up or down would be a difference in vertical, right? I
Yeah,
don't mean to be, beating a dead horse here. I just want to clarify that that's what we're talking about.
yeah, it is.
All right.
Let's see.
So that when they're laying that concrete, um, how do you think that they might have, like, I don't know. Have you ever laid concrete?
Personally, a few times, but yeah, I've watched it done a lot. Yeah.
I'm just wondering how they would finish the concrete, like to have such minute differences in elevation. I don't know.
Well, yeah, I'll be honest. I don't know. I wasn't there and didn't watch it, and haven't typically been around watching that sort of thing. And so, precisely who said what to who and how, what equipment they had out there
Yeah.
to set those things. I know what we uh, what we can do with a concrete slab, for instance. A lot of the concrete contractors will use laser screeds these days to to get the elevations right. Um, I don't know that they were using anything like that. I have no idea what technique they went through, but I know it's a very elaborate system when you look at the amount of rebar that they put in that thing and the number of control joints and construction joints that they've
Yeah. I
got in
imagine that
those
place
tests.
is.
It's amazing. Slip joints and stuff that you won't normally see in any normal construction. Where
How
they've
old
got,
is that place? It's
I
going
think they
on 30,
started.
30 years now or something.
It's from start to finish. Yeah, it goes back probably close to 30 years or so.
I imagine the concrete. I don't know. They probably didn't have the coated rebar back then. It might not have even been a
Mm,
thought, but
I actually have seen that rebar, a picture somewhere of one of those pads while it was under construction, and the rebar looks like it was coated.
hmm.
It looks like it was.
Yeah, because I know once that rebar gets any kind of moisture, it'll break down and cause all kinds of cracks and havoc.
Well, they've had
It,
problems with that in building construction. Yeah,
yeah,
high
and then
rises that have had some serious problems because of it. But again, I don't know that that really makes any difference to what the shape of these tubes is, or the shape of that pad. I won't even say the shape of the tube anymore. We know the tube is straight. The question is whether or not, and it's a fair question. You make a fair point. Can the tube be straight and the concrete under it not be straight and take all of that up with adjusters? Yeah, it could be. In theory, I don't see any reason why it couldn't be. But the real question is, why go to all of the obvious trouble and torment of pouring a pad that's the shape that it is if all you needed to do was just make some adjusters?
well, that leads me to the question, like, why do you think that it was any different than laying any other kind of pad? Like, I know that the literature and stuff like that, and the pamphlets, and part of the sell on the place was that I mean, it had to. If it's 4 kilometers long, right? How
Mm-hmm.
could they say that it's not taking Earth curve into account? I mean, that would be
Well,
a big blunder, wouldn't it?
man, well, a lot of people would have been asking a lot of questions if they would have said that. You're right, because we know the Earth's curved. We know that.
Well,
We know that you can't follow level and not over, especially over 2.5 miles, without introducing a 1 foot sagitta in the center of that thing. It's not possible.
so you're saying that if you did leveling from, like, I don't know, how long are the sections of that tube? Do you remember how long those sections are? I know FE Dogma's probably got it memorized, but
The tube itself,
no, the sections that they put in place and bolted to each section, like the individual sections, not the entirety, just the
okay, yeah,
sections,
the individual sections, I think, I don't know, are in the range of 40 feet or 60 feet or something like that.
something like that. And
It's a, it was
they use
done,
the coincidence bubble levels to level them.
actually, they didn't.
Well, they did
Well, they didn't.
on the cart. They use multiple methods to
Can you,
determine.
can you see my
What
screen?
I'm looking at the
Go to my, where,
YouTube screen here. Let me see.
you don't need
Get over
YouTube.
there.
You can do it there. Just click on my live thing here in Discord.
Oh, okay. Yeah, that's what I'm talking about.
Yeah. They're not leveling the tube. They're leveling the antenna.
Yeah, do you see that K and E plumb liner bracket
Yeah.
with the coincidence level?
Uh-huh. And
Yeah,
that's
they use
leveling
that
that.
too.
That's not leveling the tube. That's leveling the GPS antenna.
The cart
The
is
GPS
leveling the
antenna.
cart. Yeah.
Yeah.
So you're saying that they didn't cite
Yeah.
the
Well,
tube?
no, they didn't. The tube is not. It was not leveled with a coincidence bubble level. That's just
What about
that was simply used for the GPS system. That's all.
for the cart? What about the surveyors before they started leveling the ground? Do you think they used optical tools or?
Oh, I think they could have. Sure, you've got benchmarks that you can work from.
Yeah. And then after the tube was in place and they fired this thing up, um, how do you think they determined where that laser was shooting?
Oh, I wouldn't be able to comment on that. How they actually centered the laser beam in the tube. I don't know.
I think they called it first contact, kind of like the movie, but um, they shot a laser to align it.
Yeah, but you're talking about aligning the laser with the center line of the tube. We're
I
not
don't know if
talking about changing the level of the tube.
yeah, I don't know if the laser is center line with the tube or not. I don't know if it deviates to, you know, anywhere within that tube in its path.
Well, the tube was set. The the elevation of the tube to make it straight, to make it run in a straight line in all axes. That was done by GPS, not with a laser.
All right, so let me ask you about this coincidence level because I wanted to see what you had to say about it. Like what you're saying that was just for the cart was
Yeah.
so
Yeah.
when you move a level, right? Like if you take a level, a carpenter's level,
Mm-hmm.
and you're say you're checking the top of your table, right?
Yeah.
It's going to be the same if the table is of equal dimensions throughout. Say it's like 2 inches thick or whatever. You put it on the bottom of the table, it's going to be the same. It's going to show you the same, right? The bubble is going to be the same spot.
Yeah.
So if that cart is moving up and down, it's just keeping it from tilting, right?
Keeping what from tilting? The antenna?
No, well, yeah, the antenna or the table, the cart that it's on, it's fixed to the cart to make sure that the antenna is
Yeah,
horizontal, right?
Yeah, you got to keep the antenna positioned. It's a distance above that pad,
Yeah.
and you're trying to hit an elevation very precisely. And
And
that means that's like not holding your rod if you're if you're just out making sidewalks or curbing or something. That's like not you want the rod man to be holding that damn rod perfectly plumb, and that's all
well,
that coincidence level is doing. It's
yeah,
ensuring that the GPS antenna remains perfectly plumb
I'm
because
glad you brought that up.
its
Yeah.
receiver is up there at the top, and the point you're measuring is down at the concrete.
Yeah. So, I'm glad you brought that up. I wasn't going to go there just yet, but that part about the rod being plumb, like they even sell little attachments for the rod with a little bubble level, a little center bubble level, so that
Well,
the rodman can look at it to make sure that it is, plumb, right?
yeah, good rods come with that. That's right.
Well, yeah, good ones do, and I'm sure some digital ones with accelerometers and stuff like that. But I'm talking about just the principle, not
Yeah,
necessarily the tools or how expensive or how fancy the tools are. I'm just talking about the basic principle involved.
yeah. By leaning a rod toward you or away from you, you'll actually change your reading slightly.
Right.
And if you're looking through a theodolite, you're going to get a slightly different elevation that way. If
So
you're
if
and if you got a target mounted on that thing and using laser ranging, you're going to get a wrong distance too. So yeah, it's very important to keep all that stuff plumb.
yeah.
And that's all that coincidence level was used for.
So speaking of the rod and the instrument, and just not to get off of the topic of GPS because I wanted to go into that too, but just to touch on the principle of it, you've got a horizontal line that you're establishing with your level so that you can determine a rise or a drop in the vertical at the location of your rodman, right?
Are we talking about LIGO now or a construction site?
I'm talking about the basic principle of establishing elevation. We can go back to the GPS cart at LIGO and all that in a second. I just wanted to establish certain basics that we can both agree on
Okay.
or disagree, whatever. But
Okay.
just so that we're talking about the same thing and on the same page.
Yeah, I'm with you.
All right. So the rod is, would you say it's perpendicular or not perpendicular to the horizontal line established at the instrument?
Perpendicular to the horizontal line established at the instrument. So,
Okay.
if you're talking about a guy 50 yards away from you, holding a rod and looking at a bubble, and holding the rod vertical at that point, right?
Mm-hmm.
Best he can, manually, just looking at a bubble. Uh, I could say with fair confidence that there's no way in hell it's perpendicular to the horizontal that the instrument is establishing. It's going to be off by arc minutes, one way or the other. Nobody's good enough to hold the damn thing perfectly vertical.
So, well, real quick on that, are you saying that I don't know? Are you saying that your argument is based on the inability for people to measure certain things, or are
No,
you
no, you asked me.
arguing against the principle?
No, you're asking me a question that requires some further clarification.
No, I get you.
Uh,
I'm just wondering if that's your point. Like if you're saying that it's impossible to tell because the errors just inherently uh, involved by human, participation in this measuring, like would that disqualify the geometric principle that I'm trying to, point
I don't
out.
think so, because the arrow is bound to be present, but it's going to be so small that it really is not going to change anything. Now we know that the verticals are not going to be parallel to each other.
And how do you
That's
know that?
your plumb lines, and plumb lines just are not parallel. And you can
What?
prove that quite easily with a theodolite just by doing reverse zenith angles. Those angles will always add up to more than 90 degrees. If you go any distance at all, you'll
Any
see
distance at all.
any distance at all. If you go a few hundred yards, you're going to see a difference in the verticals. You're going to see a divergence in those verticals. There's always
So
an excess.
when you're okay, so if you were to use an auto level at the recommended distances, say what is that, like 60 meters?
Well, whatever distance you
Depending
can
on
whatever distance you can read the rod at.
right. I didn't want to say that, but yeah, that's right. Like, you want to be able to measure, you want to be able to see the measurement
Right.
so that you can take note of it.
Yes, and if you
Now,
can't see it, then you obviously can't measure it.
are
So
you saying that
you go to a different now you need to go to a different rod, for instance, something with coarser markings. Maybe you can't use that one that's marked in millimeters anymore. You've got to go to the rod that's marked in centimeters. And if that one doesn't work, you're probably in need of a surveyor and not a construction guy with an auto level. You probably really need then to start talking about a total station or theodolite. An auto level is actually just a construction tool. Surveyors don't really use those things. A surveyor is not going to show up and pull an auto level out and a theodolite out. They just don't do that. The theodolite will do everything an auto level will do and a lot more.
so how do you think a water level would compare?
Well, an auto level or a water level, given enough distance, is going to deviate. It has to deviate from the horizontal, which is what an auto level is establishing. Auto level will establish a horizontal plane of reference. A water level will establish points of equal elevation, and those points will diverge the further away from the longer the distance you go over. That's just the way it happens.
So you're saying that it would slope
No,
the line from point to point?
no, I'm saying level will deviate from horizontal, and it deviates at the rate of 8 inches per mile squared.
Okay, but a water level is essentially a tube of water, right?
Mm-hmm.
With two ends.
Yep.
I mean, it's not like a three-legged dog, right?
No.
It's got two ends.
Yep.
So if you take a water level and you just move one end, you're saying that the further you go, it's just going to continuously drop in elevation from that?
No, it never drops in elevation. It is always at the same elevation.
So would you say that it drops from horizontal?
Yeah, there's a deviation from horizontal. Exactly.
So it deviates from horizontal.
Yeah.
So are you saying that a water level is not a tool that's used to establish a horizontal plane of reference?
If we get into in a very loose sense and over short distances, you could theoretically say that we'll establish a horizontal reference using the two ends of the water level. But the water level is technically that line that imaginary line that you're drawing between the 2 points is perpendicular to gravity, perpendicular to the plumb bob, only at its center, no place else.
We had this discussion about the center of it, right?
Yeah.
And you said that it doesn't have. You never said that it has to be in the center. Are you saying that it does have to be in the center now?
I'm not saying it has to be anywhere. I'm saying that over
for it to
short
show
distances,
horizontal.
over short distances, the deviation from horizontal. Let's say I think the numbers we were using is something like 100 meters. Over 100 meters, it's only about a millimeter different. So it's really not enough to make any big difference to anybody. So
So
you could, you know, for the
not
for the
enough
sake
to
for the
measure.
sake of being, yeah, for the sake of simplicity, we don't have to worry about that. Not in the real
Well,
world. But technically speaking, that and in reality, that horizontal line drawn between the two ends of a water level is only perpendicular to the gravity vector at its center. And the further you go away from center, the more off it becomes. But over normal distances that you talk about, and nobody uses auto levels beyond 100 yards or so, uh, just because you can't read the damn rod anymore, right? And
so
it's a construction tool. That's really that's really the only thing it's for.
yeah, I mean, construction is just a beautiful example of geometric principles, right? Like we can build things because of these fundamental facts of reality.
Yeah, you can.
Yeah. So that's more or less where I'm coming from, what I want to really like focus on. But let me ask you, like a wall, say you build a wall and it's say 100 yards, and you take a level, a carpenter's level, like I don't know, 4 foot, 7 foot carpenter's level, and you have this straight wall. Are you saying that the level, the bubble will be different from one end to the other end of this wall?
No, there's no way you're ever going to see that with a carpenter's
Well, I
level.
agree. I don't think there's any way you'd ever see that either, but I'm
No
asking you
way.
if you're saying that that's in fact what's happening.
In a very very technical sense, to be perfectly pedantic about the entire thing, technically, yes, it is
Well,
different at every point. You only have to move a millimeter one way or the other, and there is a slight angular difference.
but if you put this
Now,
carpenter's level on this wall, where would the bubble be exactly in the center?
well, you built the wall level, right?
Well, yeah, I'd hope.
Okay, right. Well, everywhere you put the level on the wall, it's going to show level, isn't it?
But it's a straight wall. So
Uh,
are you saying that the wall curves?
it actually would curve slightly, yeah.
Wow.
If you've
So
made it
that
level, it's curving
this rigid
slightly.
structure, you're saying curves.
I don't know how many walls you've built, but they're not that rigid.
I don't know, 6 inch cinder block, steel reinforced, block walls.
Yeah, well, they lay cinder block to a line
I mean, the
full of
blocks themselves are rectangular.
yeah.
You use taut string to, identify where your straight line is so that you can match that line, and then you double check it with the level, with the carpenter's level, like a 7 foot carpenter's level or whatever, however long you got. But you got the straight line, and then you got a line level that you can put on the string to make sure that the string is level, and that level will be center all along that straight taut line, say over 100 yards, or well, maybe not 100 yards, but
Well, you don't do that.
however long you can
Yeah,
stretch that line, because the tensile strength of the line and the braking and all that stuff. I get that, but
well, the
I'm
line
saying
sags, so
within, what's that?
the lines will sag, so they're not going to go any 100 yards
Well,
with a line.
depending on the weight and its braking strength and what you
No,
got it tied off to. Yeah, yeah,
no.
yeah, yeah, yeah.
There's no way.
Just
No,
like a
no.
plumb bob.
There
Yeah,
is
you
no
can
way
you can
you can
pull it
pull.
tight.
There's no way, Mobius. There's no way you're going to pull a line 100 yards
I
and
didn't
not
say
have
100
it
yards.
sag.
No, no, no. No, I retracted that. I know that over 100 yards, the thing's gonna sag. I'm
Uh,
talking about within like a certain distance,
right.
right? Like you're building a wall. Say you go 30 feet at a time, maybe not even
Okay.
30 feet, but like 20 feet at a time, however long, depending on what string you're using and what you're tying it off to and how hard you can
Yeah.
pull that string.
Over short distances, you can use the string line. Yes.
Yeah.
But let's talk about
But what
it
I'm
since.
saying is that level, that line level that you put on that string, you can slide it up and down that line and it'll still be level.
No, it won't.
Yeah, it
No,
will.
it will not.
Uh,
You've got to hang if you're talking about using a line level, you better put that thing at the middle of the line. Do not put it anywhere else. You're gonna mess with the catenary sag in the line by doing it.
yeah, depending on the weight of the line level that you're using and the breaking strength of the line, there's all these different factors involved, right? I mean, you're an engineer, you know what I'm talking about. I might not be talking about the technical terms that you know, but you know what I'm talking about, right?
Well, yeah, I know how I know how we build block walls in reality,
I know, but I'm talking about
and
the
in
weight of the line level
yeah,
against the strength of the rope, how many pounds of per square inch you're pulling that rope, right? How tight you're pulling that rope.
well,
All those factors will determine where that line level, if it's between 2 points, will be showing level. But if you've got a shorter distance with the kind of construction string that's normally found on a construction site, you can pull it tight enough to where a half an ounce of a line level, not even half an ounce, probably a quarter ounce of a line level, won't affect the downward pull or downward direction of that uh, sag or whatever.
may not affect it much, but it will have an effect on it. Uh,
No,
it actually does. Well, if you're talking about
you're still going to be building
like,
a rigid structure to
if you're
match
talking
it.
about across the width of your garage, yeah, it's not going to make any difference really. I agree with
Right.
that. But then let's talk about maybe I want to get back to LIGO and get away from building walls and string lines
Well,
and stuff
I
like
just
that.
want to make sure that we're on the same
But
page with the geometric principles.
yeah, if you
And
want to talk
I'm
about
not sure that we're there
if you
yet.
want to talk about building a concrete block wall, let me tell you how you do it in reality.
Yeah.
You set up
Well,
you'll set up a level, probably a laser level. That's what a lot of the block masons like to use. They'll set up
well,
a
that's
laser
because
level.
they're quicker, they're
They'll set up a
easier.
laser level, and they build up leads. You know what a lead is? Like a corner or a section somewhere out in the center uh, of a long wall. They'll build they'll build up a pyramid, so to speak, and
Okay.
they'll get those elevations, the top of the elevations of those leads set properly, and from there, then they'll pull the string lines
Mm-hmm.
to break up the difference. The distance over which the string is being pulled, and then they'll just build their block up, their CMUs up to that level, up to that line. That's in
So,
reality how it's done.
right. And in reality, there's walls that are fairly long. And
Oh yeah,
what you're saying is that the wall itself, even though it's level, is gonna deviate from horizontal,
it will. It
even though it's
does.
straight.
It does. At a
So
rate
that
of 8 inches per mile squared.
so that well, you keep saying that, but I'm trying to establish how that's possible.
Well, it's possible because that's the curvature of the Earth.
Well, like again, you keep saying that, but I'm trying to establish how that's possible. So
Well,
you want to you keep wanting to say, well, we know this and this is true and this is fact and this, but we're talking about the geometric principles that lead up to that,
mm-hmm.
and you're using the conclusion as your basis for evidence to support your claim,
Well,
and that's kind of weird.
I gave you some evidence Friday afternoon. Actually, Bev gave
What's
us
that?
the evidence. Yeah, Bev gave us the evidence.
What, being 300 foot tall?
No, Bev wasn't 300 feet tall. Do you guys know? Do you know what stadium marks are?
Yeah.
Okay. Yeah, it didn't
What
matter.
about his feet being 200 feet below
It
sea
didn't.
level?
It
What?
didn't.
How was that?
You can only you can use the stadium marks several ways. You can go from the upper stadium mark to the lower stadium mark and measure that, and that's the most accurate way of using them. But you don't even have to do that. All you do is change the factor. If you go from the horizontal, from your crosshair, your horizontal crosshair, to the upper or the lower stadium mark, all you've done then, if you get that measurement correct on the object
Divide
that
it.
you're looking at, then all you got to do is multiply by 200 instead of multiplying by 100. Same thing.
Right.
So Bev's feet didn't make any difference. All I did was look at the height of that tower from the roof of the building under it to that point that the upper stadia tick was sitting on, and that's about 340 feet. Now multiply that times 200, it's 68,000 feet, and that's 12.9 miles. There's the proof that you're looking for right there.
Wait, you said proof?
That's evidence of what you're looking for. If you don't like proof, call it evidence.
Well, I mean, if
But
you're
for some
calling that
reason,
evidence for what you're trying to claim is true, I mean, you can call it evidence if you want. I don't have to consider it evidence because, I mean, to me, it's just a picture that you're going over, a flattened image on a screen with a stadia mark, and you're making all these conclusions based on this image.
no, I'm making conclusions based on established uh, techniques that are used
What I'm
with that
saying is,
device. That's all.
what I'm saying is you've got no additional data to back up anything, any kind of conclusion that you're going to make on this, right? You've got guesses and
Well,
theories and all this other stuff, but you don't have any actual data based on that picture to establish what's going on in that picture.
based on that picture that picture is very interesting, and I think it gives you well, it presents you with an inexplicable situation. You've got an auto level that's sitting, inexplicable without considering something else happening, because you've got a horizontal plane of reference that's being established by that auto level, and that horizontal plane of reference is striking the building 100 feet up above the beach. Now there's a problem there. How did that happen?
Yeah, that is a problem. I mean,
Yeah.
how do you have a horizontal
Well, does
that's
it establish a
deviating
horizontal
from
plane of
horizontal?
reference or not? Yeah. Does it have a horizontal plane of reference or not? Is that what that auto
Well,
level establishes? Yes or no?
like I said, you're not relying on any data. You've got a picture, and like I said, you can call it evidence if you want, but I don't have to call that evidence.
Okay.
I mean, it might be a piece of evidence, but it's not.
Well, you were
I
complaining
can't
about
make any conclusions from it.
you were complaining about 8 inches per mile squared, and that picture shows you 8 inches per mile squared. Once you take into account the refraction that goes on over that distance.
Yeah, I'm talking about the geometric principles that lead up to your conclusion, and I don't think that we've come to any kind of agreement yet how those geometric principles apply in reality.
What geometric principles are you? What? We've got a horizontal plane of reference.
Perpendicularity for
We've got
one.
we've got a horizontal plane of reference, and we've got an object that we're looking at in the distance, which is clearly dropped by 100 feet. What has happened?
Okay, so would you say that horizontal bends?
No, horizontal didn't bend.
Horizontal doesn't bend, but it's perpendicular. It's perpendicular to vertical.
At the auto level, yeah.
What about at the Rodman?
Again, if you move away from the point where that instrument is sitting any distance at all, vertical is going to deviate from the vertical that you had at the instrument.
And again, you're saying that without leading up with the geometrical principles to back you up. You're making a conclusion that is based on your conclusion. Like, I'm
I
trying
don't
to
think that's
start.
true. I don't think that's
Well,
true.
I know you don't think it's true, but that's what's happening. And I'm just trying to tell you that that's
You're,
what's happening.
well, you're using the nuh-uh defense.
No, you're using the nuh-uh. I'm
That's what
telling
you're
you
doing.
horizontal is perpendicular to vertical. It doesn't change where the vertical is. The vertical can be anywhere,
let's be
and
clear
it's going to
about.
be perpendicular to horizontal.
Let's
If
be clear.
vertical is perpendicular, hold on. If vertical is perpendicular to horizontal, and vertical diverges, then you're necessarily saying that horizontal bends. But you just said that it's straight.
Let's see if we can define the terms that we're using here. When you say vertical, what are you talking about? When I say vertical, I'm talking about a plumb bob. I'm talking about the direction of gravity. That's what I'm talking about. That's vertical to me. What is vertical to you?
Well, hold on. Maybe this might be the root of it. When you say gravity, the direction of down, what does that mean to you? Does that mean the center of a presupposed ball?
It means the direction of gravity. It means
okay. Well, I mean,
ultimately
down is
that
down.
ultimately
Down,
yes, that is toward the center of mass of the Earth. Yes.
I don't know where you're at in the country, but down is the same for me as it is for you. It's still down.
Down for both of us is pointing at the center of gravity of the Earth.
It's down.
It is toward the center of the Earth.
Well, that's a presupposition.
No, that's not a presupposition. That's a proven fact.
And how do you prove that by saying it? You just
as I've said,
saying it. You're not proving anything.
As I said earlier, you can do reciprocal zenith angles and see it. That's only been done about a bazillion times. Every surveyor knows that.
So you're saying vertical diverges?
Yes, absolutely it does.
Then you're necessarily saying that horizontal bends.
No, I'm not.
Then how are you establishing a horizontal if verticals diverge?
Horizontal is only established at one point, not multiple points. 1 point and 1 point only.
How do you establish a horizontal at only 1 point?
With an autolevel or a theodolite. With an autolevel or a theodolite. That's how.
A point doesn't have any information. It's just a location, a hypothetical location. It can be a physical spot that you designate as this point right here.
You don't understand that that an autolevel or a theodolite is a pendulous sort of device. You don't understand that?
Okay. It's also optical, right?
It's optical, but it's a pendulous device. It's got a compensator built into it.
A compensator?
You know what a compensator is?
What's it compensating for?
It's compensating for gravity. Let me be a little more detailed about that.
Okay.
What it's compensating for is your misalignment of the base of it.
My misalignment?
When you set it up, you only have to get the bubble within typically about 15 arc minutes. About 15 arc minutes of level. And beyond that, the pendulous compensator in that auto level will automatically point toward the center of the Earth. It takes care of it for you.
Well, it points down.
Yeah.
Yeah.
And that's your vertical.
And your optical
the instrument is then.
Read.
And the instrument then is perfectly perpendicular to that pendulum, that pendulous part of the auto level. I could pull up the pictures of the way the compensator works if you want, but I'd rather talk about LIGO.
All right. Well,
LIGO would be more fun to talk about.
I'd like to get on the same page on the geometrical principles involved, but we can talk about LIGO. What part of LIGO did you want to talk about?
Well, my question to you is very simple, and I've asked you this many times, and you don't ever seem to want to answer it, but are these or are these not the actual elevations that are reported to
Let
be.
me pull that up. What do you got?
You see it on my live.
What screen should I be looking at?
Um,
Okay, on the YouTube channel, because
well,
it's
you
not
could
showing
see
on
it.
the Discord.
It's not shown on Discord. Hang on a second. Let me see.
Not for me. I don't know if anybody else has seen it, but
I'm not
the live
using it.
stream thing that you got, it's still got the cart.
All right, I'm gonna reshare. Okay. Let's try that.
Well, you say actual pad elevations.
Yeah, as reported on the as-built drawings. Are those the pad elevations or not?
Oh, I don't know. What is this? This is Hanford.
Yeah.
Off of memory. I mean, like I said, I didn't really delve too deep into Hanford.
Well, I guess the real question is, do you question the elevation data provided to us on the as-built drawings for LIGO, either of the sites?
Do I question it?
Yeah.
What do you mean?
Do you say that those elevations are inaccurate for any reason? Yes or no?
Well, I mean, what they're based on, they're probably pretty accurate from what they're based on.
Well, they're based on mean sea level, but okay.
Well, they're based on WGS 80. Well, I don't know, WGS 84. That probably wasn't WGS 84 back then. It was probably, what was that?
Well, let's see. Hopefully you can see that.
Yeah, let's see. What's it say there?
That's what it says it's based on. This is it. The vertical datum is the North American vertical datum 88.
Yeah.
And the benchmark that they used.
80.
Yeah.
So,
and that's WGS.
I'm not,
okay. And that
yeah.
benchmark that they used is called McKinley. And McKinley can be found. I show it in this picture right here, the little red balloon there. There's the, and you can see LIGO down here in the little blue balloon. That's the center station at LIGO. So you can see the benchmark that they pulled all this from is only a couple of miles away from that vertex point.
And just for your viewers, because like I said, I didn't delve too deep into Hanford, but the Louisiana facility, those benchmarks, there were 3 listed from the NAVD 88, and those were a couple miles away from the actual site.
Yeah.
Also.
Yeah.
So
that will happen, and so they've got to transport those elevations over to the site, right?
Right.
They have to do that. So
do you think that was first order?
So here's what we got, and of course there's a description of what NAVD 88 is.
Yeah.
Right. That tells you.
Well, while you have that up,
which one?
I'm asking you, like, do you have anything that shows or talks about how they transferred that datum to the actual site? Was it first order?
Yeah, I do have something. Let's see.
All right.
Again, here's the. Well, before we get to that.
Yeah, I went through a bunch of these for the Louisiana site. Yeah. I don't have them.
There's the.
Handy. I'd have to dig through my computer to find them. I know I took some screenshots somewhere.
There's the NGS data site. NAVD 88 orthometric height is 563.9 at McKinley. You can see it listed up here, McKinley Station, Washington, Benton County, et cetera, et cetera. The ellipsoid height there is 150.229 meters, but the geoid height is minus 21.636, and that gives you. You've got to add that to the 150, and that gives you the orthometric height. Orthometric height.
How'd they get? Sorry.
Go ahead. You know what orthometric is, right?
Yeah, like a right angle.
No. Orthometric height is the well. Let's see. Here we go. There's a description of orthometric height for you that you can look at visually. Ellipsoid height is the height of the surface that you're talking about above the theoretical ellipsoid. Orthometric height, on the other hand, is the height above sea level of the surface That's what orthometric height means. Okay. So I'll go back. So when we look at this, where they say the orthometric height of McKinley is 563.9 feet or 171.878. It's actually the ellipsoid height. It's the same as the ellipsoid height plus the correction for the geoid, which in this case is negative. So you end up adding 21.636 to 150.229 and get 171.878 meters. But that was the bench. That was what they were using as their datum.
Why do you think it changed from datum to date? Or I guess what do you call it? You got the NAVD 88.
Yeah.
Before that, it was the NAVD. What was it? 78 or 74 or something like that. 72. I forget. Do you know what I'm talking about?
Yeah.
And then before that, it was like in the 60s or something. It might not have even been NAVD. It was something else.
Yeah.
Oh,
Those things have changed over time. Sure.
yeah. Why do you think
Well,
the distances are different?
the heights,
Like, yeah,
the ellipsoid, the heights of these things.
yeah.
Well, for one thing, the ground moves, and it's particularly prone to do that out there out west. When you get out in the western part of the U.S., those
But has it
elevations
moved since '88?
can change.
I mean that
Well,
structure needs
it,
it to be pretty still, right?
yeah.
I mean, in order to function the way that it says it functions.
You would hope so, but yeah, it
Yeah.
can change.
I'm
But
just
still,
wondering, like,
we're only talking now though about how LIGO was constructed, right? So
well,
you can
what
say
it's based on, right? What
you could do.
these
Let's
principles are based on?
let's see if you understand this.
Yeah.
While it's always very useful and very for us all the way around to have a specific latitude and longitude and elevation in terms of elevation above some datum like mean sea level. While it's always very useful to do that, you realize that if your objective is just to survey that site locally, you could do little more than go out there and scratch an X in the ground with the boot of your heel of your boot and drive a stake up and say, okay, that's my datum. That's going to be 0. And I'm going to measure every elevation off that point. And it would work. You realize that, right?
I'm sorry. Well,
Did that make
can you
sense?
repeat that?
Yeah. Okay, I'll try it again. The datum that was used in these benchmarks and so forth are interesting and necessary when you're doing a project like this for a lot of other reasons. But in reality, if all you want to do is lay this thing out, you could go out there and drive a stake up in the ground, put a nail in the top of it, and say, that's going to be my vertical reference. I'm going to reference everything to the top of that nail.
Right.
And that's going to be 0 elevation. I can do that. And it won't change anything, right?
Right. Just like the as-built drawings have, what is it, 0 plus 100 or whatever is they start with.
Oh yeah, they've got an arbitrary point there at the vertex.
Yeah.
And they say, okay, that's 0. Now each point's got for sure, any point on there is going to have a latitude and a longitude and an elevation associated with it. But for convenience
I mean,
sake,
it's got to be straight, right?
For convenience sake, yeah, we're not gonna start listing those things. We're going to pick a point like that vertex and say, okay, that's 0, and we're going to measure from there.
Right. So I would agree that you can pick an arbitrary point and designate it as your 0 point.
Sure.
Your starting point, right?
Yep. That's one of the LIGO drawings for Hanford.
Yeah.
They look just like the ones that you know.
No,
But
I know. I've done a lot of, like I said, I delved pretty deep into the Louisiana one. I
yeah,
didn't delve as deep into the Hanford. I dabbled a little bit. I'm a little bit familiar, but as far as, knowing things like offhand, just
right, yeah, and
from the hip.
yeah, I wasn't trying to cross you up or anything, and we could go pull all the same information out of Livingston, and I'm very
Yeah, it
familiar
really
with it
doesn't
too.
matter because the
But yeah,
principles are the same, right?
yeah, they're exactly the same. There's no difference at all. Let me go to the next sheet here. This is one. Let's see. Got to find the little thing. There we go. Now you see something else. This next drawing is one of the drawings in both sets of drawings, whether it's Livingston or Hanford. And you'll see I've got 6 circles on there, right? Uh, those circles and those circles are identifying GPS points. Let me show you. There it is blown up. Okay. GPS points, which were called LIGO 1 through 6. 6 is the one that was way off up in the out in the middle of the pasture, so to speak. But 1 through 5 are
Like at a
up.
45-degree angle from.
Yeah, they're up and down the arms. You see LIGO 5 here close to the.
No, LIGO 6. You said it's in the middle. I said like at a 45-degree angle, like from
Yeah,
the
let me.
apex.
I'll tell you what. Let me go back and I'll show you where it is. It's this one out here. That one.
So almost at a
That's
45.
like that's LIGO 6. Yeah, it's not. It's out there. It's just a geographic reference.
Right.
These other ones, though, the other 5 are up and down the lengths of the arms.
And these right here, these were for the horizontal alignment, right? Not the vertical
Well,
alignment.
they're vertical too. You see, they've got the elevations on those 5. There are
Yeah.
the measured elevations, and those elevations, those were GPS coordinate points, and as it says in the note down here, high accuracy placed by Washington State Department of Transport, DOT, geographic surfaces. So they took the elevation at the datum over there or at the benchmark at McKinley, and they transferred them to these points at the LIGO site. So that gave them known reference points that they could line up their GPS stuff with.
Right. So is that before or after they moved the dirt? That'd probably be before,
And
right?
that's before, yeah.
Yeah.
Yeah, that would have been before. And then we get to one of the arms. Not sure which one this is. Well, yeah, I am. There we go. You got a little key plan on each one of these. That's nice and handy to always have those. So it's this station down here at the vertex on the northwest arm, or what they would call arm 2, I think. And you see I just put the red line on there to show you that it's lining up with the vertex. It says that down here somewhere. But anyway, let me zoom in a little bit further on the next slide. And there you see that elevation at the vertex of 533.78 feet. Right? And the note over here that delineates or defines that top dotted line is the top of the concrete beam tube. That's got top of the concrete slab for the beam tube enclosure.
That says the tube enclosure.
Yeah, that's the slab.
The top of the concrete slab beam tube enclosure. So is that the top of the
concrete slab, like it says?
Well, because it's encased in concrete, right? They've got the concrete covers over the tube.
Yeah.
So
but this is the slab itself, not the tube, not the enclosure.
So one is the beam tube and one's the tube enclosure? Or one's the slab and one's the tube enclosure?
This is just the slab.
Okay.
This is only these are only the elevations of the slab, that's all. But you get that.
It says tube enclosure there.
Top of concrete slab, which is for the beam tube enclosure. That's what the beam tube enclosure sits on.
Oh.
Now, we've got other drawings that will show that if you want to see them. I'll have to go to the as-builds and find them, but they're in the details.
Mm-hmm.
So there's like the vertex end of this thing. Oops. And well, let me back. Did I get ahead of myself? I don't know. Yeah, there's the end of that same tube. Here you go. Let me look down here. We were looking at this one a minute ago. Now we're looking down at the far end of it, right? Now we're all the way down at station 13,100. And when we zoom a little further in, where you can see it, there you see that elevation, 529.63. So the other one was 533 feet. This one's 529. That's the 4-foot slope that these things have.
Real quick, while you get that slide up.
Yep.
Because this is something that we talked about before, and I know you wanted to go over the decimal placement for, how you average or you round up, to certain things. Like you've got the 3 over there on the left at 126, 127, 128. It all has the same. And the next diagram or whatever that would be the 126, 125, 124, and so on, right?
Mm-hmm.
That'll have a certain elevation mark on there, and it says, what is it, 529.64 feet, 529.64 feet, 529.64 feet.
Yeah.
And those are how many feet apart?
100 feet.
100 feet, right? So there's 200 feet right there that has the same elevation. And you're saying that I want to be clear what I'm talking about here. I'm not saying that you wouldn't have a rounding thing going on, but where do you get your information from what the precise measurement would be? Is it from the geoid, the orthographic, or the ellipsoid, or which one of those uh, models? Which one of those models would you be getting that precision from? Because you rounded it off to what, the 4th or 5th decimal point at one point
Well,
in a video.
I think maybe I did. I don't remember.
Do you remember what you were
about
referencing?
about all of
Which
that.
model?
But what I'm not using anything other than these
Well, you
reported
said
elevations.
you used a prescribed radius value
I'm only
to
using
get that sort of precision. You used a prescribed radius value.
Well, yeah,
I don't
you
know
would
if you
have.
remember in your video you pointed it out.
Sure, and that's what you
So
would do.
is that
But
prescribed radius value the orthographic model, the geoid model, or the ellipsoid model,
well, orthometric, not orthographic, but
or the spherical
or
model? Because the sphere is different than
these
the
are
ellipsoid. The ellipsoid is different than the orthographic, and the orthographic's different than the geoid.
orthometric is not
Orthometric, right?
is
Okay.
what we're talking about. These are
Yeah.
orthometric heights. These are orthometric elevations. That's
So
above
when
the
you
geoid.
factored in the precision to the 5th decimal point, were you using the orthometric model
When I
with the
factored in,
prescribed?
I'm not sure what you're talking about. When
Well,
I
you used an
factored
exact
in,
measurement for a radius to come up with the exact precise measurement to the 5th decimal point for these differences in elevation.
I don't think you ever understood what I was showing you.
You
And
were
that
showing
seems to
me
be the
that
problem.
a decimal can be rounded up to the nearest
I'm showing you that if you take
value.
if you take a theoretical perfect curve, right, that is varying at a rate of 8 inches per mile squared, which corresponds to a radius of 3959 miles,
Mm-hmm.
and you do just strictly a mathematical calculation of what the elevation should be, and you carry them out as many decimal places. You can carry them out 50 decimal places for all I care. But when you round them back
Right.
down to what was actually measured, which is only to 2 decimals, it works perfectly. That's
Yeah,
all I was showing you.
and I never
My
disagreed with you.
information.
You made all these different comments about my intelligence based on this stuff, and you didn't ever even give me the opportunity to explain that I understand exactly what you're talking about.
Well, do you understand now what I'm talking about?
I
These are the
understood
actual
then, Loop.
measurements. These are the actual measurements.
I understood then what you
These
were
are the
trying to
actual
do.
measurements. You were
I just
questioning
want.
why I
I
always.
just. No,
You were
no.
questioning Mobius. Okay, you go ahead.
Are you okay? I was not questioning where you were getting this information from. It's obvious where you're getting this information from. You're using a prescribed value to then calculate hypothetically a more precise value up to the fifth decimal point.
Well, let's be clear about what you were doing. You were questioning why this thing is 564, 564, 564, then 563, 563 over these distances. That's what you were questioning. Why is this pad flat over those distances? That's what you were trying to say. And all I was showing you is that it isn't necessarily flat. Those are not necessarily precisely the same elevations if you had the ability to measure them beyond 2 decimal places, but they don't. That's measured to 1/10 of a foot, which is no, 100th of a foot, which is 1/8 of an inch. And that's all I was doing.
1/8 of an inch.
Yeah, 1/8 of an inch. These are accurate to within 1/8 of an inch.
Because here at
100th of a
129,
foot.
it's 529.63, all the way up to 133 is 529.63. That's
Yeah. And
how
all I
many
was
hundred
showing.
feet? That's 1, 2, 3. That's 400 feet showing the same elevation. And
Sure.
you're saying that that's within a range of 1/8 of an inch.
That's exactly what a circle does, Mobius.
So 1/8 of an inch over 400 feet.
Yeah, that's exactly how a circle behaves. Precisely.
I'm just asking you if you're saying that 800 feet, you get 1/8 of an inch difference.
Yeah.
So how do you measure that in reality? Like, how would you?
Well, you don't. You don't even try to. They're measuring as well as they can here at 1/10 of a foot or 100th of a foot.
And
that's very precise for
and they're doing that with what?
For concrete, huh?
What methods are they using for that?
Well, I wasn't there, but you could do that. You could do that the old-fashioned way with just a theodolite. You could easily measure those elevations. Now, you believe that, right? If you go to one end of this thing, say this bottom end, and say 529.63, that's my benchmark. That's my zero. Then I can start walking my stick up that pad in 100-foot increments and taking measurements of it, differential leveling it, and come up with every one of these numbers. Do you believe that? I believe it. I don't think you'd have any trouble at all doing that. The numbers you see there on the page.
Yeah, the same numbers at 129 as 133.
Yep, I think that's exactly what you can get.
So you're getting the same elevation, but you're saying that there's 1/8 of an inch difference?
No, I said the resolution there is to within 1/8 of an inch. That's 1/100th of a foot.
And
12 inches times 0.01 is 0.125. That's 1/8 of an inch. 0.12, which is almost an eighth.
These elevations were established before or after the thing was built?
These things are called as-builts.
So after?
That's what as-built usually means, yes.
Okay. So these particular values were derived from standard old-fashioned optical tools, or were these the GPS values?
Yeah, I told you I wasn't out there, so I can't tell you whether they actually used GPS to do this. They could have, but you could just as easily have done it with a theodolite.
Okay. But the cart that you you showed earlier, that has a GPS on it, right? And that was used
Well, that's used for straightening the tube. Yeah,
for straightening the tube.
yeah.
So we don't have the values for that, for the center line of that tube somewhere.
No, I don't have them.
Because I looked for them too. I didn't see the length of the tube, the values of that center
I'm
line.
not sure. I'm not sure who's got them or where you would find them. Honestly, what I know is what was reported in there in the paper that they presented about how that thing was aligned, and they claimed the RMS deviation of 4 millimeters or something like that over the
Those
length of it.
over that length
Mm-hmm.
with the laser in a vacuum, right? Light in a vacuum, the deviation.
Well, that's not the laser in the vacuum. Again, we're back to that. But
Oh, well,
no,
maybe we're
I
talking
think
about different
no.
documentation. I saw somewhere where it talks about the deviation of light in a vacuum over so many, so much distance.
Yeah, I'm not sure about that. Let's don't confuse the alignment of the laser beam itself with the
Well, that would be the light.
straightening of the tube itself.
Like I said, I don't know where the light is in reference to the center line of that tube. And we don't really know where that tube is in reference to that slab. Right. So I don't know.
Okay.
There's a lot of unknowns still with all of this.
Well, all that boils down to this, though. These are the as-built elevations plotted on a horizontal
line.
scale. Yeah.
Yeah.
And this is what it looks like if you try to plot that thing using sea level down here 0 and going up to 600 feet above sea level. That's what it looks like. It's just a straight line. You can't tell, right? But when you expand that a bit and make your y-axis begin at 529 feet and go up to 534 feet, you get that curve from the actual pad elevations that are shown on the LIGO as-built drawings. Now that is clearly not a straight line. But I wondered then, what would happen? If we looked at what happens to this, and this is, by the way, all the data I've taken on that one arm. This is why I haven't done it on all 4 of the arms. There's a lot of work involved in doing it. But I went to every one of those drawings and I pulled every one of the as-built elevations off, and that's this second column that says as-built elevations. But then I did a projected 8-inch per mile curve. So if I take each one of these distances, divide it by 5,280, and then square it, right? And then times 8 divided by 12.
Wait, what?
I'm just generating an 8-inch per mile squared curve, beginning in this case at the 533.78 foot elevation, and then you'll see this is just theoretical stuff. Okay, 8-inch per mile.
I get that.
And it goes, and you'll see this thing drops and drops and drops. Let's plot that, and when you do, you get this orange curve. That's the 8-inch per mile curve. That's that data. Now that's what would happen starting at 533 point whatever, and causing it to drop at a rate of 8 inches per mile squared. Wow, it's almost exactly opposite the combined actual as-built elevations, which are the blue curve. So what happens when you average those? Well, you get a perfectly straight line, and that's what LIGO's pad does. It forms a perfectly straight line.
So I'm just curious. The 8 inches per mile squared curve that you factored in there,
Yeah.
which is almost exactly opposite of the blue line.
Mm-hmm.
Which model did you use for the 8-inch per mile square curve? Was that the sphere, the ellipsoid, the orthometric, or the geoid?
8 inch. Maybe you're not aware of this, but 8 inches per mile squared is just the standard number that we use for Earth curvature, or drop from horizontal.
So which model would that fall under? Would that be the, I mean, is that like consistent over the entire sphere?
Oh, actually, it changes a little bit
Oh, okay.
because the sphere is not perfectly spherical, is it?
Well, a sphere is a mathematical model.
Yeah.
It's a mathematical construct of, you know,
Well,
an
technically,
exact. Well,
technically, a
it's
sphere
two
is
dimensional, right?
really just the surface of a ball.
Don't you guys say that it's two dimensional?
Well, the surface is two dimensional, but that's not an
Well,
argument I want to get into.
oh, you don't want to get into the whole 2D, 3D argument?
No, it's a definition. I don't like arguing definitions. By definition, a surface is two dimensional. So
You'd be surprised how many people take it literal that it's two dimensional.
it's a conceptual sort of thing, like a plane. There's no such thing in reality.
I'm just telling you, there's a bunch of people in your Discord, people that troll our Discord that, you know, say that it's literally two dimensional. But whatever, I don't want to get into it either. It's
All I wanted to
but
show,
I just want to know.
what I wanted to
You've
show,
got like
though,
pretty exact numbers here, right? I mean, you've got a pretty good representation here, and that orange line. I just wanted to know if that's based on a sphere with a fixed radius, or is it the ellipsoid with
it's
an
actually
alternating?
well, it's actually based on, I think, I'm safe in saying this, 8 inches per mile squared is based on an absolutely perfectly symmetrical sphere with a radius of 3,959 miles. I think that's right.
Right, the prescribed
Yeah.
spherical
And is it
radius,
different?
which would be a straight line, right?
Is it different at different points on the
Radius.
Earth? Yeah, it certainly would have to be, because the Earth is not perfectly spherical. It's squished a little bit. We know that. But, okay, for over the distances we're talking about, over 2.5 miles, it doesn't matter. We'll just go with 8 inches per mile squared. That's the number we always use. So let's see what happens when we apply 8 inches per mile squared, and that's what happens. This orange curve is what happens when you do that. When you start subtracting 8 inches per mile squared from that starting elevation of 533 whatever, you get this orange curve. But when you take that orange curve and average it with the blue curve, which is the actual elevations, then you see the straight line. This was just an easy way of doing it. Now we can get into some.
Oh, go ahead. Sorry.
We can get into some fancy math and do it otherwise, but this was just an easy way to show it to you.
Yeah, no, I agree. It's very simple. I just wanted to ask you, like, you say actual elevations.
Mm-hmm.
Now, how are these elevations acquired? How are these quote unquote actual elevations acquired?
Well, that's what we've already been talking about. Those are the elevations from the on the as-built drawing.
Oh, that's right. You said you didn't know. I'm sorry.
Yeah, I can't tell you that. I can't tell you for sure if it were happening today. I can guarantee you that it would have been by GPS. But in that time frame, I'm not sure it would have been.
Well, no, GPS had just gone out to the public domain, and that's when they went ahead with the construction. Like, the planning and all that stuff was pre-GPS, or pre-public access. And then
GPS had been going for a while, because they were
no, it
using,
had been going for a while, but it wasn't in the public.
This has been in the public for a long time. I think the construction of this thing started early.
You might want to look into the LIGO documentation on it, because it specifically talks about how they were hoping to use GPS, but it wasn't quite yet in the public domain. And then once they did issue it to the public domain, then they were able to utilize that for their construction.
It
You
had
might
been
want to.
well, it had been in the public domain for quite a while. I had a GPS receiver in my airplane in 1995.
Mm-hmm.
The only
Well,
thing
like I said,
the
I
only
mean,
thing it
this
wasn't
was
good for in those days, at that point, I didn't have a GPS system that was capable of allowing me to fly instrument approaches because the elevation data wasn't good enough, which
yeah. Well,
it finally became.
even
But
even 5-10 years ago, it was an error of what, like a meter or something like that.
oh,
The
it still can
elevation.
be. Yeah, it still can be. Depends on
Yeah.
what sort of GPS you're using.
Yeah, and that's the
And
vertical,
and whether or
right?
not you've got RTK, real time kinematic correction going on. That's
Yeah,
the secret to the accuracy of these things. And now, when you want to get down into millimeter accuracy, that's when you start needing corrections. That's when you start having to have base stations set up over a known point that can provide offsets. Uh,
right,
because
and that's a pretty
yeah,
complicated mathematical system. I mean, it's a computation. It's really complex, right? Like the what do they call it? Least squared adjusted. It's almost like a statistical analysis type level math.
yeah, it gets pretty complex. I agree with that. But no,
But
I
the
guess I got to.
horizontal, what's that?
Oh, go ahead. What about the horizontal?
I was just going to say that the horizontal of the GPS is far more accurate even today, right?
Not necessarily anymore. Um, you can get
Anymore,
vertical. You
what?
can get very precise vertical uh, information. Uh,
But the horizontal has always been pretty much easier to obtain.
well, horizontal was when I first started using GPS. That would have been the early '90s, I guess. When I first started using it, horizontally, you were good for within about 30 feet, maybe.
Hmm. Like 10 meters.
But as Larry Scott points out in the chat, phase differential GPS for precision work became a commercial tool about 1990.
I'm
So
just
it's
going
been
off of what the stuff I read on LIGO.
yeah,
I mean,
It's been around quite a while. But I guess I've got a question then, and my question is pretty simple. What
mhm.
is it about the LIGO data that you would like to question in terms of that pad, in terms of that blue line? Forget the green line or the orange line. What about that data causes you to
Well, I don't
question?
have any question about it. I guess I would ask you what your thoughts are on how the information is obtained, how that data is obtained. Like, what's it derived from? Because you said that they didn't use. Well, sorry, you didn't say that they didn't use because you didn't know, you weren't there when they did it. But um, the elevation data, like what it's from. You said the NAVD 88, mean sea level, WGS 84. These are all hypothetical models, and you brought
But
up the
the
orthometric,
but the
which is
question,
also, what's
yeah,
that?
but the question really is back to what I said a while back.
Mhm.
Forget about the absolute the orthometric height of any of this stuff out there. If I would have gone out, if they would have gone out there, if we went out there today at the vertex of those tubes and put a nail in the concrete and said, okay, that's zero elevation.
Mhm.
Do you think that we could take just a conventional theodolite, or an auto level for that matter, and go down that beam tube or that pad it's sitting on and recreate these elevations that are plotted here, or not?
Well, I don't know. I mean, I I would like to take a a water level, like a 30-foot, 100-foot piece of water level, and just go down the length of it and see if that deviates by the time I get to the end of it.
Yeah, that'd be
I mean,
interesting, wouldn't it?
there's a ditch along both legs of the Louisiana site, and it's got water in it. I mean,
Well, the one that slopes has got a dam in the middle of it too.
well, I mean, there's yeah, every once in a while there's a little bit more dirt in the ditch than other places, but that's just dirt. That's not that's not the what do you call it? The hypothetical model. Because when you say the surface, like what are you talking about? Are you talking about the actual dirt? Like did they go up or down with the dirt, or are they going up and down from a hypothetical reference surface?
Well, I'm not following you.
Well, mean sea level, right?
Yeah.
When you hear mean sea level, say mean sea level is uh you know, what'd you say, 339.69 or 30, what'd you say?
Well, mean sea level is sea level, period.
All
Now,
right, so what elevation would mean sea level be?
zero.
Okay. All right. So we agree that mean sea level, we can designate that at zero.
Yeah.
But when you picture mean sea level in your head, you picture it as a ball, right?
Well, I picture the Earth as a sphere. Yeah.
Well, like your profile picture, that's how you picture mean sea level, right? Like just
Okay. Yeah.
a prescribed radius from a center.
Yeah. Okay.
Well, I mean, how do you get that from measuring from a horizontal?
How do I get sea level from measuring from a horizontal?
No. How do you get that image in your head from measuring from a zero, right? We designated mean sea level, bam, zero.
Yeah.
We stuck a nail in the concrete. We're going to call that our zero datum, and we're going to go horizontally from that. We're going to measure up or down an elevation from that horizontal to
Uh-huh.
determine what we want to be straight, right?
We're going to measure up and down from that point, up and down from that point to obtain orthometric heights of every point along that.
What do you mean
Uh,
orthometric?
well, maybe orthometric wouldn't be the best choice in that case, but an elevation differential. All right, let's just call it that.
Okay,
Well,
the difference in elevation.
we're going to call it point zero, and then we're going to go up and down that pad, and we're going to say, okay, the elevation here has changed negatively by however much, or positively by however much, and that's what we're going to do. We're going
So
to
on that,
use we're going to use points of we're going to be referenced to that point that we set as zero. Now that's zero elevation, right? And we're gonna use that as the reference all the way along.
okay, so like that blue line that you got there
Yeah,
on that diagram,
yeah.
you're starting at zero at the vertical. Let's just say the vertical, the versus the feet,
Mm-hmm.
the elevation feet.
Yeah. If you want that to be zero, then you can easily see what the graph's going to look like.
Or I'm sorry,
If
the
if
horizontal, the station.
Okay.
numbers on the bottom on the horizontal there. We're starting at 0. We're going to go to we're going to call that 530. What would that be?
Five, five,
535.56.
well, I don't know what.
I don't know. It
You
looks
talk
like
about
it's
that
just above half between 33.5 and
five,
34. So
yeah, 533 point whatever it was, eight.
five
Let's call
six, 5.8,
it five. Yeah,
whatever.
533.5
Anyways,
something.
that's
Okay.
beside the point. But you're gonna start at that 0 station, and you're gonna go out 100 feet,
Mm-hmm.
and you're gonna use your traditional tools, or let's even say a water level. You're gonna use a water level for that first 100 feet. Would that the other end of the water level, would that be higher or lower than the water level at the one spot?
Well, you're going to go out 100 feet with your water level. Okay, you're going to set your water level at that point, and then you're going to start down this slab, right? And at 100 feet, you're not going to see any change in the water level. We've already seen that on the in the data. And at 200 feet, you're not going to see hardly any change. In 300 feet, but eventually, you're going to start seeing it change.
Well, would you say that it would
Actually,
be from 533.58 to 533 point, what would that be?
well, that's
5.3 over 200 feet?
it's whatever the data said. There's the data. Let's see. We started at 533. Here's the actual right here. The actual.
Where does it show the
It,
difference?
hmm?
Where does it show the difference from horizontal to not horizontal? Do you have any of
Oh,
that
I didn't
worked
put
out?
that. I didn't put that in there. I mean, we can do
Uh,
that. If it's important, I can do that in a spreadsheet
it's
very
not.
easily.
I'm just wondering, like, if you've got traditional tools and you're trying to set your elevation for this thing that's supposed to be straight, would you set it higher or lower than horizontal?
I'm not sure how what you're trying to get at, Mobius.
Well, that blue line, if you go back to that blue line,
Okay.
that other diagram,
Yeah,
that blue line looks like it dips down, like it's
it does. There's a
right.
4.5 foot elevation change from one end to the other, or a 4 foot.
So what I'm saying is, if you're going from horizontal, which you're saying would be the green line, or
No,
no,
that's not
that's not the
hard.
green
No,
line.
no,
That's
no, no.
just a
That's not
slant. That's a slant,
hard.
right?
Yeah,
That
right.
goes from 533.58 to what, 529.52, something like that.
Yeah, something like that.
So that would be a slant. So
That's a
would you
slope.
be
Yeah.
following, yeah, slope? Would you be like a water level if you're going like in 100-foot increments?
If you're going in 100
Would
foot
it be
ink,
following that green line or that blue line?
the slab itself.
No, the level of the water and the water level, because the water level will establish a horizontal plane of reference.
No, the water level will establish 2 points of equal elevation.
But it's a straight line between the 2 points. Like, do maybe I should share something on my screen. I don't know.
You
I'd have
can.
to dig around and try to find something. But do you have any pictures of the water level you can throw up there? Do you know what I'm talking about?
I've got. I don't think I've got a water level drawing handy, but I mean, I can. I think most everyone listening can envision what we're talking about here. It's just a tube with water in it. That's all.
You'd be surprised how many people have no clue what a water level is. They think it's a carpenter's level.
Well, they get spirit level and water level mixed up.
Well, yeah, but it's just astounding how many people are. I wouldn't. I don't know. Maybe ignorant to it. I don't want to use strong offensive words, but there are some people that have no idea what a water level is, and it's literally like one of the oldest tools known to man, but maybe besides a rock.
Well, if we had our theoretical water level, which is 13,100 feet long, and we set
Wait,
it up here at the top, uh, and we started moving along with the water level, it will follow that blue line.
it'll follow that blue line?
It should. Those are the
Didn't you?
elevations.
Wait, you said that the
I
blue
said
line
I
is
follow the
straight.
blue line. The differential is the differential in the pad in the water is going to follow that line.
Now, is the blue line is that
Actual
level?
elevations. That's actual elevations.
Okay, but is that level or is
No,
that
no, it's not level.
horizontal?
Can't be level.
So that
Can neither
blue
be
line in
it
this.
can neither be level nor horizontal.
Hmm?
It's neither. It's neither level nor horizontal, right?
Oh,
It's
because you're
sloping.
saying it slopes. Yeah.
Well, I'm not saying that. It does. It's actually there. The elevation data tells you that. It slopes there's a 4 foot change in elevation over 13,000 feet. So
I
the
thought you said before that the tube is a horizontal.
no, I've never said the tube is horizontal. The one of the tubes at
I have a
Livingston,
recording of you saying that the tube is horizontal.
one
I
of the
can pull
tubes
it up.
one of the tubes at Livingston is almost horizontal. But the other tube at Livingston and both the tubes at Hanford have a 4 foot slope in them. None of them are actually truly horizontal by my definition, which would be perpendicular to the gravity vector at its center point. None of them are.
So it slopes down
Yeah, it absolutely has to.
compared to what? Like
Compared to sea level.
what's the reference?
Compared to level.
Well, what's the reference that it's
Level.
sloping from?
Level.
It's sloping from level? I thought you said level isn't horizontal,
Level isn't horizontal.
but it's sloping from level. Like how do you determine a slope from
Okay.
something that's not straight?
Okay. If this is one end of let's call it 533.5, just to be
Okay, 533.5.
we'll say that's the end of the tube. Level would be if this bottom end of it was also at 533.5. That would make it level.
Okay.
All those elevations at 533.5 would be level.
Well,
But
if you look at the grid on the sheet that those orange, green, and blue lines are on,
mm-hmm.
those are straight. So if you're saying that would be level, if it's 533.5 at 0 and it's 533.5 at 13,000, then that would be a straight line.
That would be a level line, which is not straight.
But you're using a straight line as a reference to tell me that it's level and
No, I'm
not
not.
straight.
No, I'm not. I've given you the actual elevations and plotted them in an elevation profile
Yeah.
to show you what it looks like.
Yeah.
Each one of those elevations on the abscissa there, 531.5, for instance, is a point a consistent elevation all around the Earth. 531.5 is a level, what we would call level elevation, but it is not a straight line. It is a curved line.
I'm saying that the diagram here,
Yeah.
right? If you took 533.5 at 0 station feet,
Yeah. Mm-hmm.
and you moved it to 13,000 station feet,
Yeah.
that 533.5,
Mm-hmm.
that's that gray line of that grid that you're
Yeah.
using as a reference to determine where 533 is at 13,000 station feet. All right, that's a straight line, and you're saying that that's level, but it's not Straight.
It's level, but level is not straight
Because why?
because the Earth curves. Because level implies an equal potential, equal gravitational potential. That's why.
So vertical.
That necessarily invokes a curve with a radius of 3,959 miles.
Okay,
That's
like I
why.
said, so vertical, right?
Vertical. What do you mean?
Equal potential would be vertical.
Equal gravitational potential, the same distance away from the center of the sphere.
So would you say that gravitational potential is vertical? Plumb? I thought we clarified this earlier that vertical is plumb. You said that's how you would define vertical. It's plumb.
Yeah, vertical is to me vertical is plumb. Yes.
Okay. And
And
if
in reality, if we wanted to be really, really crazy about this, none of those lines on that piece of paper there, or on that graph there, would be straight lines. Every one of them would be curved. All of the horizontal lines would look like frowny faces, and the vertical lines would be skewed from each other.
wait, what?
In reality, that's really what it is.
Oh,
But the difference is so stupidly small. We don't
yeah.
ever do that with an elevation diagram. That would just be crazy.
So
That
like
would
if I
mean
turn that
that would
if I
mean that would mean that each one of those horizontal lines would be an arc segment. And let's say we made that arc segment like 20 inches long. We would need, in order to draw the next arc segment for the next foot of elevation or next inch of elevation, we need a compass that has a beam about 300 yards long or something like that, something ridiculous. So, practically speaking, in CAD we could do it, but we've been drawing these elevation diagrams like this since the beginning of time, basically. And we just don't show it like that. It's just impractical and there's no point in it. We all understand that an elevation is a curved line. It is following the curvature of the earth.
well, like I said, you keep saying that, but what I'm trying to focus on throughout this conversation is the basic principles that you're using to establish that as a fact. So far, it just keeps coming up as a claim, and trust me, I get where you're coming from, but I think that you're like not wanting to address the principles involved. Like you you'll say that horizontal is a straight line and that horizontal is perpendicular to vertical, but
Yeah.
then you'll say that verticals diverge, which would necessarily mean that horizontals aren't straight.
No, it just means that horizontals. It just means that horizontals are peculiar to and particular to a specific point. That's all.
So how can you have a horizontal at a straight when clearly the horizon, which is horizontal, is from way left to way right? Like what? That doesn't make any sense, Blue. I'm trying to understand how you're uh, able to process that, how you're able to rectify that in your head, how a straight line can only be what it is if it's not a line. And that doesn't make any sense to me. I'm trying to wrap my head around it.
Well, makes sense to me. But
Well, because
that
you've got this mean sea level is a ball in your mind, and I'm just trying to break it down to like the fundamental geometric principles that like everything is built upon that we use to construct things in reality. And you even said that this diagram right here that with the blue line and all that, like you can do that in CAD, but it'd be completely impractical to do in reality because it'd be so minute. Like, how do you even know that that's what it is, what it's doing? Because the model dictates that that's what it has to be doing. Not because you know this in reality, because admittedly you said that you weren't even there. So you don't know how they establish these different elevation marks. I know that you read that, you know, it comes from the NAVD 88 and the WGS 84 and the orthometric, bless you, the orthometric, the geoid, the ellipsoid, the sphere, all these different, you know, mathematical constructs, these very complex mathematical systems that
No,
take all these different things into account.
all
But
these
there's not any one person or a team of people out in the field that are doing these things in reality that are coming up with this stuff.
Oh yeah, there are. But now
Not without the model in the pocket.
let's back up a second. And you're talking all about NAVD 88 and geoids and ellipsoids and all of that stuff. And I'll go back to what we started out with. None of that makes any difference whatsoever in terms of this blue line. These elevations were not made off of the geoid. These elevations were not taken from some model or the other. These things were taken from a datum, from a benchmark out there at that job site. Those are the actual measured elevations of that pad.
And
That's what you're looking at.
I asked you because obviously the datum wasn't at that site, right? They had to transfer that datum from offsite to that site and designate that vertex or
Okay.
that one, right? That one starting point. They had to designate that with something, right? And they went from a known NAVD 88 benchmark some
And
mile or so off site.
but
So I
once
asked you
you
how they transferred that datum, right? And you didn't know. I asked you if it was first order or whatever, but we
oh,
didn't
I'm sure it
really.
was, but I mean, let's but again, what difference does that make to the shape of this line? Once you have that established point, and you have said, "This is my project datum. This is my project benchmark. I'm going to call it 533 point whatever." Everything then is being measured off of that. And if that was wrong, if the actual orthometric height, the height above the geoid,
I'm
isn't
not talking about.
533, it's actually
Yeah.
531. Who gives a shit? We're
I'm not talking
using
about if it's right or
533.
wrong
We're
compared
using
to a model.
533, and we're looking at the elevation change from that point, from that vertex point, all along that pad. That's what we're looking at. That's all.
Look, I'm not saying that it's wrong based off of whichever model. Okay, if you start with the model and you do those calculations based on that model, then you're going to come up with things that are accurate to that model.
This is
I mean,
not a model, Mobius.
it doesn't
These
take
are
a
measured
math
elevations.
genius, huh?
This is not a model. These are measured elevations.
Measured off of what?
Measured off that benchmark, from that benchmark. Measured
Off of the ground?
The
Off of the
benchmark,
ground
Mobius. The
from a
benchmark
horizontal?
from that benchmark elevation.
And I'm asking you, is it measured from a horizontal reference or is it measured from
It is from a point,
a
a
hypothetical
datum, a
reference model?
benchmark is a point.
Right. I know what
It's
a
not a
benchmark
horizontal.
is.
It's not a
It's
level.
one location.
It's one point. And from
Right.
that, you measure a change in elevation from that point.
Blue, I don't know
That's
why
all.
you think I'm disagreeing with you. I'm not saying that it's not. I know
Okay.
that a benchmark is a datum. I
Well,
know that a
then,
benchmark is a single location that you designate with a certain elevation.
yeah, exactly.
Right. So
That's
why are
all
you
it is.
saying that I'm not saying that? Why
Well,
are you saying I'm
I don't know
arguing
what
with
point
you?
I don't know what point you're trying to make.
Well,
These are the elevations as they
I'm
change with respect to that benchmark, that point.
and
That's
I'm
all you're
asking
seeing.
you, how did those elevations that change from that benchmark, how are those elevations established from that benchmark?
They're typically established by a surveyor with a theodolite or a
With the
total station
theodolite.
or a total station.
So it's a change from the horizontal.
Do you know what a theodolite does? I know Bev doesn't understand these, but do you know what a theodolite actually does?
I
It's not a.
don't know
It's
how
not an.
that's.
It's not an auto
I know
level.
it's not an auto level. I've told guys in your chat that a theodolite's not an auto level. I know it's not an auto level. What I'm asking you is if that change in elevation is a change up or down from horizontal.
Is the blue line a change up and down from horizontal? Absolutely, and it's also a change from level.
Well, yeah, I would agree
It's
that
sloping.
a change from horizontal is also a change from level.
It's sloping.
But you're saying that level is also a change from horizontal.
It is, absolutely.
And how would you justify that statement?
By the simple fact that is the fact. Those are the facts. We can
you
measure.
Can't go to court. You can't go to court and say,
I'm not in
telling
court.
the truth because I'm
I'm
telling
not
the
in
truth.
the court. I'm not in court.
I know.
We can
Lou,
measure
but
the
I would hope
radius
that
of
you
the
would
Earth,
give me
and we have. I've done it.
At least that minute amount of respect to not be that belligerent about, how you support a claim, right? You don't just say, I'm right because I'm right.
Well, that's what you're doing.
Suck it. No, that's not what I'm doing. I'm asking you to support and justify your claim.
I want you to support yours. You're claiming this is wrong. Tell me why.
I'm not claiming that it's wrong. I'm asking you how it's right.
You're making the claim that these elevations, this is what I thought we would come down to.
We established that horizontal is straight.
You are claiming these elevations do not accurately represent what's on the ground out there. And I'm asking you, where's your evidence for that?
We established that horizontal is straight, right?
We established by my definition of horizontal that it is a straight line perpendicular to the gravity vector at one and only one point. That's what we established.
That's okay. So are you saying that horizontal is not horizontal at another point?
Exactly. And
then
we know
how
that.
Can then if you've got a series of points from A to B, say, I don't know, 10 feet apart, whatever, give whatever distance value you want. But if you've got from point A to point B, you've got a different horizontal at every point in between, that would be necessarily a curving horizontal because you're establishing that horizontal at a vertical datum.
The vertical has changed too, Mobius.
If you're
the vertical moves too. The vertical is a radial.
The vertical would change.
The vertical is a radial.
I swear to God,
it's a radius.
So if you look at this graph paper that you've got, which you say technically it would curve also. Well, okay. Instead of getting into like the quantum realm to describe straight lines curving and shit like that, let's just keep to what's on the screen. So these gray lines that go across the screen from left to right, right?
Yeah.
I'm going to say that is horizontal.
Well, you'll be wrong.
Then how do you know that green line is sloping away from horizontal if you don't have anything to reference from?
That green line is the green line and the orange line are a couple of imaginary lines I put in here just to help you see.
The green line is the sloping line. It's a sloping line.
The green line is the average of the orange line and the blue line.
I don't know what happened. I don't know why you got so defensive all of a sudden.
It's a simple average. That's all it is.
Yeah,
it's really just a good way to see. It's a good way to see. It's a good way to see.
So much.
Well, nothing scared me. You seem to be a little frightened for some reason. I don't know why.
No, I'm just wondering why you're so defensive all of a sudden.
Oh, I'm not being defensive. I'm just simply trying to point out to you that all
you're
I was
saying
doing
that those gray lines going from left to right aren't horizontal.
Those gray lines
saying
going from. Okay, you go ahead and you talk.
no, I'm just saying that's a horizontal line. I'm trying to communicate with you something, and I feel like you don't want me to communicate it. I don't know if it's because we're live right now. I don't know what it is, but I feel like every time I try to get to some basic fundamentals, like you put up roadblocks.
Well, I think I've been very clear with you, Mobius. Those horizontal lines on this type of elevation profile are representing lines of equal elevation, but in reality, equal elevation is not a straight line, it is a curved line. We know that. It is a curved line that
You say you know that.
Yes, we know that because we can measure that. We have measured that. I have measured that.
How have you measured it?
Well, actually, using the Eratosthenes method, along with another guy that's about 10 degrees north of me, and you can prove very quickly what the circumference of the Earth is and that the Earth has
Hold
to
on.
be spherical or it won't work.
Your whole basis of understanding is sticks and shadows.
Have you ever done anything, Mobius, yourself? Have
I
you tried
have.
measuring it?
I've been looking into this shit for a long
Have you
time.
done it?
Yes, I have. I've tried it. I've done the pendulum thing. I've done the shadows thing. I've done the horizontal thing. I've gotten the auto level. I've looked. I've gotten water levels. I've done these things.
Have you?
But blue, yes, blue.
Okay. Well,
I've
don't
worked
get excited now.
construction. No,
Don't get
I'm just.
excited now.
I feel
It's going
like
to be okay.
this again is another one of your roadblocks,
It's not a roadblock, Mobius.
and it's just I don't know. It's hard to understand why you're getting defensive like this.
I'm not being defensive, Mobius. I'm just telling
Yeah.
you. I'm just telling you those horizontal lines that you're looking at on this graph paper are representing lines of equal elevation, and in reality, those lines are not straight; they're curved.
I
Period.
asked you to
And I told you why
your
I know
statement.
that.
I asked you to justify your statement
And I told you why I know that. But there are
because
many,
of
many.
Eratosthenes.
But there are many, many, many other ways that you can do that.
You said you measured this curve.
Yeah, you can't do Eratosthenes at two different points and come up with any conclusion other than the sun is a long way away and the Earth has to be spherical. You can't get the numbers to work any other way.
This stuff that you're showing on the screen right now, these are not measurements that you've taken to verify that this is what's happening.
Well, I did not take the elevation data on the pads at LIGO. No, nor did you. So
nor did I. I never claimed that they were, anything.
I didn't claim anything either, other than that's the reported elevations.
You said that is how it is. That we know that this is how it is because that's how it is.
Mobius,
I asked you to justify how you know it, and you said, "Well, because I know it." I mean, that's just ridiculous.
I know you're caught, Mobius, but
I'm not caught. I'm asking you to justify something,
really
and you said, "I know it's true because I know it."
What are you asking me to justify, Mobius? 8 inches per mile squared. I told you how I justify it.
I'm asking you how you know, and then after that little spat, you came up with Eratosthenes. So nothing about LIGO gives you any information that you can point to and say, I know this is true.
Well, let me tell you what about LIGO it does tell me. It tells me that pad curves at a rate of 8 inches per mile squared, yet the tube that sits on it is perfectly straight. That's what I know.
So the elevation data that is in the documentation, which is based on a mathematical model, a mathematical hypothetical model.
Negative. It's based on measurements made in the field, Mobius.
But you weren't there, Blue. How do you know?
Okay, then that's what I thought you would do, and that will conclude our discussion. You were questioning the validity of the elevation data as reported by some of the largest engineering firms on the planet.
They even
That's
say that it's a
okay.
hypothetical model.
Okay.
Why are you disagreeing with LIGO's documentation, or with GPS, or with
Where does
WGS
anybody?
84? Why
Please,
are
I
you
want a
disagreeing
citation.
with
I
these
want a
things?
citation right now. Where does any of the LIGO documentation say that these
That
elevations are hypothetical? Where?
it
Show it
it
to me.
says that it says that
Show it
they're
to me.
based on NAVD 88. It says that they're based on WGS 84, and
It does not.
it says that they use GPS.
Okay. All right. That's what I thought.
What's what you thought?
That's where I thought you'd go.
What, that they use these
That the
things?
that the elevation data is hypothetical. That's exactly where I thought you'd end up.
Well, you're not showing me any different. You're
I've
telling me that we
I've
know
shown you the
it is
drawings
what it is
and
because we know what it is.
I've shown you examples of
I've
the
seen the
drawings where the
drawing.
elevation data is recorded,
I know.
Mobius,
I've
and you
seen the
can choose not
drawings.
to believe that, but that is the elevation data.
I'm not saying that it's false.
Well, then what are you saying? Make your mind up and say something.
I'm
You're
saying that it's that these things are represented based on a hypothetical model, which you can't deny that, Blue. If you're going to deny that, then you're gonna be arguing with GPS. You're going to be arguing with WGS 84, NAVD 88, all these different reference models. You're going to, I mean,
you can't be serious. You really cannot be serious.
you yourself said that you haven't measured this. So what are you basing your knowledge of any of this on?
I'm simply basing it on what I've told you I based it on. Reported elevation data signed off by registered professional engineers at very, very large companies that wouldn't
Okay.
dare do this and put their license at risk if the data
Those
was
very big
false.
companies, those guys working for those very big companies
Mm-hmm.
also realize that WGS 84 and GPS is based on a hypothetical geoid model. It's a reference.
What is a geoid model, by the way? What does the geoid tell us?
That it's got different radius values at different various places on a reference ellipsoid. I mean, it's just a different, you know, value than a reference ellipsoid, which is a different value from a reference spheroid, which is a different value from a reference orthometric. I mean, you can't be serious that you don't know this
Oh
or that
goodness.
you're arguing against it.
Oh my goodness. Now I was just curious if you knew what the geoid actually is.
What is it? You tell me.
Well, it's a deviation from the ellipsoid.
And how did I say
It's
that
how it's
that's
how water
different?
it's how sea level differs uh, from the ellipsoid model, which there are a
How
number of. They differ slightly.
how's wait, there's a difference what?
The geoid is simply the difference between sea level and the ellipsoid.
How did I say that it's not? That I
What?
use different words?
I don't
I
know what. I
I
don't know.
pretty much said the same thing. It's a different.
Okay, good. If that's what you said, then you understand it. That's what it is.
Okay, so where's the disconnect? What's happening?
The
You
disconnect
said,
is
"Oh, I thought
the
that's what you were gonna say," and blah blah blah. That
well, yeah, that's what I
concludes our
thought.
conversation.
It's
And
exactly what I thought you were going to do. You're going to question the elevation data.
am I?
That's the only way out you've got.
Am I
Because
questioning the elevation data?
clearly, if you believe the elevation data, that pad has got a great big smiley face. See the blue line? A nice little smiley face to it.
I don't know how you're
If the
getting
elevation
around
data,
this.
if the elevation data is real, that's what it looks like.
I
But
didn't
if
say
you
it wasn't real. It's based on a hypothetical model. Of course, it's going to be, representation of that hypothetical model.
so
What
it wasn't actual measurements made in the field. It's just a hypothetical model.
the measurements are clearly not made from a horizontal reference. You
They're elevation. They're
Already said that.
elevations. They're elevations, Mobius.
Yeah, elevation
Each
from
one.
what? From what
Each one is
reference?
an elevation. Huh?
From what reference?
Well, from any datum, any benchmark you want to pick.
Okay, let's pick 533.55.
Okay. All right, that's good. That's a good benchmark. Let's call it 0.
Okay, we'll call that 0.
Then the elevation at the other end of the tube is about -4 feet.
And you know that because it's
because they measured it.
a difference from a horizontal?
Because they measured it. They measured a
Measured it
difference in
how?
elevation.
And how
Elevation
did they measure
measurements. Elevation measurements, Mobius.
I didn't
You can
ask
do
you
this.
what again.
You
I
can
asked
do
you
this.
how.
Huh? I wasn't there, Mobius. I told you that before. I don't
So
know
you
if
don't
these
know
guys. Do you know how they could have? Tell me 2 ways they could
Well,
have.
I know
done
how elevation is measured, and it's
How
measured
is it
from a
measured?
horizontal reference,
It's not necessarily.
vertically.
No,
Well,
not
explain to me
necessarily.
how it's not.
Not
So
necessarily.
you're telling me that I'm wrong.
Not
So
necessarily.
your nuh-uh is your argument.
If you want to do elevations, what do you normally do? If you want to do, want to do a differential leveling procedure, how do you do it? Do you know?
Well, I establish a horizontal, and then I
Do
measure
you?
vertically. Huh? Yeah.
Okay. Yeah, all right. Now, walk me through the process, Mobius. I'm going to take
Walk you through.
Yeah, I'm going to take an auto level because I'm too dumb to run a theodolite. I'm going to take an auto level and I'm going to do an elevation
Wait,
profile.
you're
going to
use an auto level because you're too dumb to use a tool that does the thinking for you?
That's what I'm trying to make it easy on you here. Okay. I'll use
Sorry,
I'll just use an
okay.
auto level and let's do differential leveling on this
Oh,
thing.
goodness.
Can you tell me how you would do that? Where would you set your auto level to begin with? Hmm.
I don't know what game you want to play here, Blue.
I'm not playing any games. I'm just trying to get you to answer the question.
I know that you're aware of how differential leveling works.
Mm-hmm.
So why are you asking me to go walk you through the process? Just so that you can interrupt me.
I'm not going to interrupt you. Go ahead. In fact, talk all you want. I want to take about a 2-minute break. Is that all right? Could we do that?
You know what? That'd be great. I actually have to pee anyway. Do you have some
All right.
background music or something you can put on?
I wish there. Well, I'll tell you what. Everybody in the chat right now, hum to yourself your favorite fight song for whichever team you root for, and we'll be back in 2 minutes or less.
You back, Blue? All right, just let me know when you get back.
And I made it back.
All right.
Okay,
So,
where were we?
well, I don't know. Not sure exactly. I wanted to know how a well, you asked me to walk you through the process of differential leveling, which I think is just, I don't know what your point is, because I think that you know how differential leveling is or how it works.
Well, if you think that, then if you went to LIGO, do you believe that if you did differential leveling on that pad, you would end up with a line that looks like that blue line or not?
Well, like I said earlier, um, I I don't know what would end up, right, what results I would end up with. I think, if the thing is straight, if the pad is straight, then it would be straight. If it's not straight and the tube is straight, then the tube would be straight. And if the tube isn't straight and the pad isn't straight and the laser is straight, then the laser would be straight. But I told you earlier that I would like to take a water level and see what kind of deviation I would get by doing like 100-foot runs all the way down to the end of it. But we could use an auto level, theodolite, whatever, and compare. But what I'm trying to focus on is the fact that we would be comparing from a horizontal reference. We wouldn't be comparing from a non-horizontal reference. And you say that horizontal is only horizontal at that point where the instrument is.
Right.
And I say that necessarily means that that you're saying that horizontal bends,
No,
because
and that's a
each
misrepresentation.
so you're saying that a horizontal will increase in elevation on a vertical datum.
Absolutely, just like Bev's Blackpool picture. That's exactly what it will do. Exactly the same thing. Shout out
So a
Bev, by the way.
horizontal,
Yeah.
so a horizontal, which is parallel to the horizon, will raise in vertical
There will be
datum.
there'll be a deviation between horizontal and level. Yes.
So what about left to right?
Well, we don't do this left to right, do we?
Well, why not? Why don't you do that?
Well, you're only looking 3 miles.
Horizontal is left to right,
You're only
right?
looking 3 miles away. Why? Why?
If
Why
you're
bother?
standing vertical and you're looking left to right, horizontal is left to right, right? That's horizontal. That's parallel with the plane of the horizon.
Okay. What about it?
Well, where does that deviate?
All the way across. All the way.
So if I set a line of
But
poles on the horizon, and each one is vertical, and I step back and I'm looking at these poles, which one is going to be not perpendicular to the horizon or to horizontal?
well, we're getting way away from LIGO now.
Well, I'm
Let's.
trying to I'm still trying to figure out if we're on the same page with the geometric principles, and I don't think that we are, because I mentioned horizontal on your graph paper here being the gray lines going from 0 to 1400 on that sheet of paper. I'm not talking about your globe induced reference, I'm talking about on that sheet of paper, that those gray lines are horizontal.
On that piece of paper, you could say those lines are horizontal if you like, but they represent.
I'm not talking about what they represent. I'm
They
talking about what they
represent
are.
equal elevation.
I'm talking about what they are, not what they represent. I just
Okay.
got done telling you that.
So you're asking me if that piece of graph paper has horizontal and vertical lines? Yes, it absolutely does. Congratulations.
Okay, God, at least we can get past that. That's a step forward. Thank you. So, with that being said, you know that green line, even though you say that it's a, just a made up imaginary line to represent whatever you said that it represents, I'm just using that line that's on the sheet of paper. We know that that is sloped because it deviates from that horizontal.
Mm-hmm.
Right. Okay. Good. I think we're on the same page. I'm not saying good like, ooh, I got you. I'm saying good that we're on the same page. I'm trying to communicate.
Let me tell you again what the green line represents. It's simply the average of the orange line, which is an imaginary curve at 8 inches per mile squared, and the blue line, which are actual measured elevations. That's what the green line is.
I know that you say that, and
well, I did it. Of course, I say that. That's exactly what I did. I'll show you the computations if you want to see them.
I know that you used your fixed radius at 3969 or whatever the hell numbers you used for the value.
Mm-hmm.
You use that as your reference, and
all I'm doing is showing you that the blue curve matches 8 inches per mile squared exactly
compared to a model, right? Where's that model?
8 inches per that curve. That blue curve is in reality. That blue curve are those are the actual elevations measured at LIGO, not theoretical, not hypothetical, no model induced anything.
You don't know how they did it.
Those are simply measured elevations. I told you two possible ways of doing it. They may have used conventional optical leveling techniques that any surveyor knows how to do, or they could have used GPS, even at that point.
So they made a straight line that deviated from horizontal.
There's nothing horizontal about it, Mobius. What are you talking about?
I'm talking about in reality. We already established that a horizontal is a straight line, right?
It's not hard. This is not a horizontal situation. You've got an elevation change. It is a slope. The tube slopes from the vertex down on this particular
from horizontal
northwest arm.
Are we not in agreement that
it slopes down from level? From level, it slopes down, and yes, certainly from horizontal. It certainly slopes down from horizontal, but it slopes down more from level.
Wait, slopes down more from level than horizontal?
Yes,
I thought you said level slopes down from horizontal. So wouldn't a slope from level
if horizontal slopes
horizontal?
If horizontal is sloping down, level is sloping down even more. What is so hard about this? You seem to be geometrically challenged here.
I seem to be geometrically challenged.
Yeah.
How so?
You don't understand. You don't even understand how the Earth actually works. Level deviates from horizontal. Level always deviates, and the further you go, the more that differential becomes. That change from horizontal. In this case, the horizontal is sloping down, but level is actually
sloping down from horizontal.
Of course it is.
From horizontal.
It's a slope, Mobius.
So the horizontal is sloping down from horizontal.
The horizontal.
Is that what you just said?
The horizontal, you can see right there what we're talking about.
I'm asking you straight out. Is that what you said? Did you just say that horizontal is sloping away from the horizontal?
I
If
did
you
not.
didn't, that's fine.
I don't think that's what I said, but whatever.
Pretty sure it is, but I just wanted to give you the opportunity to clarify because it sounded stupid.
No, we don't need to start doing that, do we?
No, and we don't
If
need
you'd
to
like to.
tell each other that we're geometrically illiterate. I'm trying to come down to like a common understanding between the two of us. I'm not
I
trying to
don't think
insult
that's
you.
going to
Mike.
happen. I don't believe that's going to
Well,
happen.
It might not.
I don't see any possibility that that's going to happen.
But maybe you can shed some light as to how you rectify these certain concepts in your mind so that everybody watching can go away, take away from this a better understanding of how you develop these processes in your mind.
Well, this gets more tricky as we go along, because what we're talking about here are the actual elevations of that arm, but in fact there are two of those arms. Now those two arms actually form a triangle, if you want to draw a triangle out of it. You got two arms at 90 degrees. Connect the other two of those arms, and somewhere within that triangle, according to the LIGO documentation, somewhere within that triangle, that plane that those two arms are forming, do you agree that that would be a plane? You got two lines intersecting at 90 degrees.
If you've got a right angle, you basically got a square. Yeah, I would say that.
Would you have a plane?
Or you got a triangle. Yeah, you got three coplanar points. Let's go with that.
Yeah, you got 3 points because you have two lines.
Any 3 points can be coplanar. Got it.
And those form a plane, right?
Okay.
And according to the LIGO documentation and everything they say, and I believe it too because I've looked at the information, and that's what it looks like. That plane is tangent. That plane itself is tangent to the surface of the Earth at some point within that triangle. There's a point of tangency for that plane. It's not along either one of these arms.
I just want to ask you real quick, are you going with this FE dogma stuff?
What do you mean, FE dogma stuff?
Well, FE dogma had had two tangent points on one of the arms, and one tangent point shared a tangent point with the other. Yeah, you guys even said that he did because you were using two reference surfaces.
He did
two
not
spheres
have two
that were separated from each other at different elevations. That's how you guys worked it out. I was there.
He did not have two tangent points on the same arm. He did not.
Not on the same sphere. They were two different
not
spheres.
On the
Isn't
same
that what you
arm.
and Rumpus were going on about?
Not on the same arm. That was the lie that Bev told.
No. You guys had.
That's the lie you guys were telling.
Two different spheres where one elevation was a tangent point and the other elevation was a tangent point on a different reference sphere.
Yeah,
that was at a different elevation from the other one.
And that
so
can
the
be
arm
true.
that was straight had two tangent points, but they were on different spheres.
No, it did not.
But it had different spheres.
No, that each line had a tangent point to a single sphere. They happened to share a common elevation, which was not the tangent point.
How can you have two spheres? What
it is a sphere. You can have how many you don't believe you can have concentric spheres? Is that what you're telling me now?
Are we talking about?
You don't believe that you can have concentric circles, and that if you spin that, you turn them into spheres?
Wait. Are you talking about in general, or are you talking about Earth?
I'm talking about just in general. Can you have concentric spheres?
Yeah, obviously, yes.
Okay, if the Earth is a sphere,
then you can have concentric circles.
Okay, if
the Earth is a sphere,
if the Earth is a sphere, then you've got then you can have concentric elevations. Yes. Okay. Absolutely.
So in reality, on Earth, how do you have two different spheres?
You have these are elevations we're talking about, and elevations are spherical in nature.
So
when we look at them,
each vertical datum is a different sphere?
Each vertical datum is a different sphere. Actually, yeah, that's what it would be. That's exactly what it has to be.
Right. That's exactly what it has to be. Just like if you've got horizontal perpendicular to vertical and verticals diverge, horizontal has to bend, has to curve, has to be in the shape of a sphere.
No, it doesn't.
Oh, I don't know how you're going to get a perpendicular to a sloping vertical or slanted vertical.
You don't know how to get a perpendicular to a line. Should I explain how you do that?
Well, if you look at your graph here, the gray lines that go left to right,
Mm-hmm.
if we call those horizontal, and the gray lines that go up and down, if we call those verticals, then the ones to the far left are the same as the ones to the far right. They're all perpendicular. All planes perpendicular to another plane are parallel.
You're talking about a graph. You're not
I'm
talking about
I'm
reality.
talking.
In
Well,
reality,
how do you have a
each of
horizontal
those
plane
elevations in
at only one
reality,
point?
each of those elevations is a different sphere.
You say that, and I'm asking you, in reality, how do you have a horizontal plane at only one point?
You're not seriously asking me how you have a tangent to a circle. Really? Is
No,
that
I
what you're
didn't say
asking me?
anything about a tangent. I said a horizontal plane.
That is a tangent to a
So
circle.
you're saying that
That
a horizontal plane
is a
is a
tangent
tangent.
to the circle at a point. Yes, that's
And
what I'm
how do you
saying.
justify that statement? You haven't
I
even
don't.
established
I don't
how a
need to
horizontal
justify that
plane is a
statement.
horizontal plane perpendicular to vertical.
I don't need to justify that statement.
Oh, okay. All right. You're right. You don't have to. You don't have to justify anything that you say. I just want to hear you say it.
How do you justify going against that?
Going against
What is
what?
your justification for
That a
saying that's
horizontal
not how it
plane.
works?
Well, a horizontal plane
How do you
is made up of at least. Hold on a second. You asked me to justify it. I'm justifying it, and I'm saying that a horizontal plane is made up of at least 3 coplanar points.
you
And
don't need to say
those
three coplanar? Just say
within those 3
3 points.
coplanar points exists a plane which is perpendicular to planes that which is the
Be careful.
horizontal. It's just a matter of wording. It's the way I word something doesn't change how it is. All right, so just relax. A plane exists of 3 coplanar points. Lines that are perpendicular to that plane will all be parallel. Horizontal is a plane, and you said, we both established that it doesn't bend. It doesn't curve. You argued back and forth that it doesn't curve. So we're both in agreement that it doesn't curve, right?
That horizontal doesn't curve?
Yeah.
Yeah, it doesn't.
Okay. So a plane, which is made up of 3 coplanar points, is not a plane at any individual point. It's a plane because it's at least 3 coplanar points. And within that 3 coplanar points, every location on that plane has a perpendicular to it.
Yes, I agree with that.
Vertical is perpendicular to horizontal.
I agree with that. Hold on a second.
You were trying to say that.
No. Wait a minute. Let me address what you said.
That vertical.
Three coplanar. You got 3 points, and they identify a plane. You don't need to say. You don't really need to say 3 coplanar points. That's redundant. But
okay. It is redundant.
We have
just for clarity. Just for clarity.
We have a
plane. Because you said that I'm geometrically illiterate.
And we can have that to that plane. We can have an infinite number of lines that are normal to the plane. Let's use that word. perpendicular to the plane in all directions,
Wait, wait,
meaning
wait.
normal. Is that
Why are
not
you
true?
changing terms?
Huh? I won't change
Why are
terms.
you
Okay.
changing? Now you're
Perpendicular
bringing
to the
up.
plane.
Well, first
Okay.
of all, I tried
Were
to
you
say
happy?
horizontal, and you said
What are you
it's a
happy with?
tangent.
What are you happy
Then I
with?
said it's vertical, and now
All
you're
right,
saying
you're
it's a
not gonna.
normal.
So you're just gonna Fundy mute me then? Okay. Whatever.
No, I'm answering your question. You asked me a question. I'm answering your question. Why are you going to interrupt me while I'm answering the question that you asked?
Well, you're rumpusing me for one thing, but let me. What the point I was trying to get to is, I'll go along with you that we could have an infinite number of verticals. What you're using a lot of terms interchangeably. Do you like vertical or perpendicular or normal? Which one of those terms would you prefer I use? To me, they're all meaning the same thing when we're talking about this plane and lines piercing the plane. Okay, we could call them
So
verticals, we could call them perpendiculars, or we could
any
call them
any
normal.
plane,
So, which one of those terms do you like the best? I mean, I'll use it. Okay. Because here's my question: regardless of what you call it, how many of those, how many of those verticals that you're talking about can be tangent, can be at the point of tangency of that plane to a circle, to a sphere? How
sorry,
many?
ask that again.
How many
I was
verticals?
doing something.
How many
What?
verticals in that plane that you're talking about that has all these verticals that are all perpendicular to the plane? How many of them simultaneously can be at the point of tangency of that plane to a circle or a sphere?
Point of tangency.
Mm-hmm. The point where that plane touches a sphere, how many verticals can come from that point?
Infinite.
An infinite. Oh, okay. Thank you. So you can have an infinite number of verticals all through that one point.
No, you can have an infinite number of verticals on that perpendicular to that plane.
But only one of them that passes through the point of tangency of that plane to a sphere.
No, vertical has nothing to do with that circle or that sphere. Vertical's not a radial.
I'm trying to move along a little bit to
Well, are
something,
you
a
saying that
concept
vertical
that's
is
a
a
little more
radial?
advanced. Yeah, that's what I'm saying.
That's what you're saying?
I'm saying that the plane that we're talking about is tangent to an elevation spheroid, if you want to think of it that way, at one and only one point. And there's only one vertical that can pass through that point. One and only one.
Okay, so
And it's headed in the
100 feet
direction
away,
of the center of the sphere.
100 feet away from that that one vertical.
Yep. That plane
Where's
is no longer tangent, is it?
no, I'm asking you where a vertical would be. Because if I got 3 points making up a plane, each one of those points would be perpendicular to vertical.
We've already established this, Mobius. Every point, every vertical you draw on that plane is perpendicular to that plane. But only one of those verticals can be perpendicular at the point of tangency of that plane to the sphere.
Okay, why are you introducing these terms tangency to a sphere? Like why would you introduce that?
Is that too okay?
It's not complicated. I'm just wondering why you're doing it.
Well, you were talking about horizontals here in this horizontal line.
Yeah,
That
and
you what you're calling
you haven't established the words tangent to a sphere. You haven't established that group of
I'm not
words
here.
yet.
I'm not here to teach you math, Mobius. Come on.
I don't need a lesson in math.
Yeah, you
I need a lesson
obviously
in
need a
how
lesson.
you rectify these thoughts. Like it boggles my mind how you put the cart before the horse.
I
It
don't
just
think so.
yeah, you
I
do,
don't
Blue,
think so.
and everybody sees it. It's just amazing.
Oh, I think everybody is clearly seeing what's going on here. Yeah, no
Yeah,
doubt about it.
everybody on your side, I'm sure, thinks that I'm a complete idiot and that I'm illiterate mathematically and all this other good stuff. I'm sure you got all kinds of colorful insults ready for your little circle jerk later, but I'm really wondering, like, how you can say that a plane, which is of three coplanar points, is perpendicular to the same uh, perpendicular at all 3 points, but you're bringing up this tangent to a sphere as if that like how do you justify that, like bringing those terms into it
It,
without first identifying that you've got a perpendicular relationship between one plane and other lines going passing through it perpendicular. I just don't understand how you're like skipping forward so far without first establishing certain basic fundamentals. It's crazy to me.
I don't think I'm skipping forward at all, but
I know you don't. That's what's mind-boggling. Like you're not a dumb guy. I mean, you're an engineer, you've been a professional your life. Like I just don't understand how you can not see what you're doing.
well, I don't know exactly how to respond to that, Mobius. I really don't. The Earth that I live on is an oblate spheroid and an imaginary plane, because all planes are imaginary when it gets right down to it. Can be can be tangent to some point. Every plane in the universe, if we moved it over here, could be tangent to one and only one point on that sphere. And that means that only one of the verticals, the normals to that plane, would pass through that point of tangency. That's my point. That's
I
all.
guess I just don't see the connection
And
between, a horizontal being a reference from which you measure elevation from vertically to vertical only being at the point that you're at. Like
well,
how can you measure a slope from horizontal 10 feet away if that if that vertical isn't perpendicular to the vertical where you're at, or isn't parallel with the vertical that you're at, isn't
it,
perpendicular to the horizontal
well,
that you're using to measure the elevation difference. It doesn't make any sense. It's not square, you know.
no, it's spherical. You're
Right,
right. It's not
it's not
square.
square. Like,
It's not
like
square.
when the word correct, it is like it stems from rect, like rectangular, rectilinear, these things. It means right, like correct, right angle, square. Like these things are built into not only our language but fundamental principles of life. And
No,
I don't know, it's just weird that
I
you
suppose I've got
don't square this up.
I suppose I've got an equivalent issue with the way you guys think, which makes absolutely no sense to me.
I'm sure that there's a clear disconnect. It's just hard to put my thumb on it.
Well, it starts with this idea that level is horizontal, and it is not.
Well,
And
I think go ahead.
thanks to our friend Bev, he proved that with his auto level and Blackpool Tower. Very
I
nicely done.
I
So,
think your definition of proof is pretty loose right there, but whatever.
well, okay, then let's say this: he observed a drop from horizontal with his photograph.
Let's say this: you observed what you interpret as what you think it is. How
Well,
about
you
that? Would
haven't
be
given
more
me
accurate.
something else. You don't have anything else to give me.
I just, if we can keep it honest, that would be great. I think
Well,
that
that
that would
is
be more
honest.
accurate.
That is honest.
Okay, well, saying that I'm right because I'm right isn't very honest. I'm just saying. I don't think anybody.
All I
I
know
don't.
is that Bev showed us a picture, and clearly a building in the distance has dropped by 100 feet. Now, you tell me why that happened. Because it matches a curvature of 8 inches per mile squared exactly.
Look, Blue,
How did that happen?
I'm not of the mind that, this
But
just comes out of thin air. I'm sure that there are things that people see and observe, and they interpret these observations as something, and then they build this model based on these observations, off of these interpretations from these observations, and then everything that they interpret after that that points to that model they say is correct, and everything that points outside of that model they disregard and discard, and they try to rework and all this other stuff. And so, I mean, it's been a long time coming, this like complex, sophisticated model. I don't
I think it's actually a
I
very
don't think it
simple
just came
model.
out from nowhere.
I think it's a very simple model.
Well,
And
yeah,
it
because
perfectly, and
you've
it
grown
perfectly
up
explains,
you've grown
no,
up
no, just a
believing all
moment.
this.
I think it's a perfectly acceptable, perfectly usable model. What I like about it is the simplicity of it. It very simply and very accurately predicts exactly what we observe in nature. On the other hand, we try to take what you guys do and make any sense out of it, and it's just a mishmash of bullshit to
Hold
try
on
to
a
make
second.
it do anything.
When you say you guys, what do you mean? Because I'm just talking about measuring a vertical change in elevation from a
Okay,
horizontal reference.
okay.
What do you mean, you guys?
I mean, everybody on your side of the fence, and I'm not going to
My
call it
side of the fence.
your side of
So
the fence.
everybody that says that,
Might be,
everybody
might
that
be,
measures
might be.
elevation for from a horizontal reference vertically, everybody that says that is my side of the fence.
I suppose. I,
Well,
if you want to say it that way, but no. The point is these elevations that LIGO provided in as-built drawings do not plot a straight line, and you still have no explanation for why that is.
I've tried to discuss it with you. You got defensive.
You still have no explanation. Well, I'm waiting. Give me an explanation. Why does that blue line curve?
Because it's based on a hypothetical model. I've
Then you're
said
saying
this.
that the tube at LIGO is curving.
No, I'm saying that the values given the elevation values are based on a hypothetical model. Of course, they're going to represent that hypothetical model. I'm not saying anything about the tube, the concrete, the laser beam, any of
What a,
that. I don't
what,
know. I've never actually visited the facility,
what
but
about those? What about those
but I will tell
elevations?
you,
Is based
but
on
I
a
will tell
model,
you,
Mobius.
I will tell you that the values that are based on a model are going to represent that model.
How do
Period.
measurements? How are these measurements based on a model, Mobius?
What?
How are these measurements? These measured elevations. How is that based on a model? Other than if you're going to try to claim that the sea level elevation is based on the geoid. If you want to say that, okay, I'll go along with it. But how does the difference in those elevations? How are
If
they
these
based on a
elevations,
model? How
if these
how
elevations,
how are they
okay,
based on a model?
trying to answer you. Sorry, I didn't know you were going to ask me 3 times in a row. Um, how are these? How is that blue line based on a model?
Yeah. What model is it based on?
It's I don't know. It's based on a reference geoid. I don't know, GPS,
Oh,
whatever model that they
okay.
use in their programming.
All right, fine. The
And the
starting elevation.
WGS 84. I
Then
mean,
you're saying
those are very complex mathematical programs.
then you're simply saying the starting elevation is wrong. But now, what about the rest of them?
I'm not saying that
You're saying that the
the starting
benchmark
elevation could be
is in
whatever.
question.
We could arbitrarily designate the starting elevation.
Okay. Now we arbitrarily designate a starting elevation, and we make measurements of the elevation of that pad,
And
referencing
how do we
simply that starting elevation. How is that based on any model? That is a simple set of measurements. How could that possibly be based on a model? I don't understand. This is very simple stuff.
right? Well, I'm
But
asking, well, all right, how is that based on any model? Well, it's representing that model.
It's representing that model.
Those values come from
Measurements.
how measurements with what? Measurements
With
from horizontal?
With measurements with whatever tool they were using to make elevation measurements, and that could have been,
and that's the key.
all of those things that we've
using?
talked about. It could have been a water level. It could have been a dumpy level. It could have been an auto level. Could have been a digital auto level. Could have been a theodolite. Could have been a GPS system. Could have been any one of those things, and they would all return the same set of elevations. All of them.
You say that, but what tools did they use? I'm saying that the
does
key
it matter? Why does it matter?
It does matter.
It doesn't matter. It doesn't make a damn one way or the other, Mobius. You're just squirming trying to find a way out, but you're caught in this trap, buddy, and there's no way out for you.
All right, buddy. Look, I'm trying to ask you if this was based from a horizontal reference. You don't know. I'm asking you, what tools did they use? You're saying it doesn't matter. And I asked you, well, if I use the water level from here to here, are you saying that that water level is going to drop from horizontal? Then you got all crazy and upset. I don't know how you want to have this conversation. Okay, then answer.
Answer what?
Does the water level, when I go from one place to another with the water level, does that water level, the level of that water, is it above or below the horizontal?
I'll answer it this way. If you took your water level out there and you set it up at the elevation of 533.5 or whatever that upper one is, and you have a water level that's, say, 2.5 miles long, and you go all the way out to 13,100, you would measure, that water level would show you a 4.5 foot change in elevation of that pad. That's what I'm saying.
Well, first of all, I wouldn't take it all that way. I mean, I wouldn't need to, because I'd want to make sure that everything in between was level. And that's not 1,300, it's 13,000. But
sorry.
Regardless.
I misspoke. 13,000. Yes, there will be a 4 foot change in the elevation, regardless of how you do it.
So you're saying that there would be a 4 foot drop from our zero.
Yeah.
We'll call that our horizontal distance, 0 to 13,000.
Yes. There'll be a
4 foot drop in my water.
Yeah.
And you know this how?
That's what they measured, Mobius.
Who measured?
Jacobs Engineering.
Wait.
Caltech,
You said with the water level. I'm asking you, who measured that with the water level?
Nobody measured it with the water level. You're the one that brought up the water level. I'm answering your question about what would happen with the water level.
And I'm asking you how you.
Nobody but a window-licking idiot would go out on a job site like this and pull out a water level. That is ridiculous, Mobius.
I didn't say it wasn't ridiculous. We're talking hypothetically. I would take a water level.
How many construction sites have you ever been on where somebody pulled out a water level to try to level a pad 2 miles long? How many construction sites have you ever been on?
That's a ridiculous question. That's not what I'm saying.
Yeah, it is what you're saying.
It is not what I'm saying. I'll say it again. It's not what I'm saying.
That's not what you're saying, because you say that's not what you're saying.
Do you want to address what I'm saying?
That's what you said.
Do you want to address what I'm saying and not make up some stupid shit to try to make me look dumb?
Oh, I don't. Because that's what you're doing right now. I don't need to do that.
Okay, then let me talk. And
quit, so you're questioning
making up things that I'm saying. I'm not saying that anybody's ever done that.
You are questioning whether or not there's a 4 foot elevation change. That's what you're questioning, right?
I'm asking you how you know that.
Because that's what the drawings report, and I take I'll take their word for it. Absent any evidence to the contrary, I'll go along with what is presented on that set of as-built drawings. Now, you may choose you may choose to say that's wrong. I've got to be able to verify it. I need some testimony. I need to go to court. I need this. I need that. I don't need that.
Shit up? That's not what I'm saying.
All I need is a set of signed drawings from a professional engineer that says these are the elevations. That's good enough for me.
All right. So if you're at the 0, right, of our horizontal distance, and you take a water level from 0 to 13,000, you're saying that you will get a 4 foot drop and you know this because they did that at LIGO.
I'm
but
saying
didn't
that
use
because
a-
that's what
a
the
water
elevations show. Yes, I'm saying that's what will happen because that's what the elevations show.
So I'm asking you, if I take it in 100-foot increments
Hmm.
all the way up to 13,000,
It's still going to drop 4 feet.
it's going to drop from horizontal.
It's going to drop from level 4 feet. Those are
Which
elevations.
is lower?
Those are
Which is lower?
elevations.
Level or horizontal?
Which is lower?
Yeah. If I'm looking straight out, am I looking? If I'm looking horizontally, if I establish a horizontal, would level be above it or below it?
Oh my God! You know the model as well as I do. Don't ask
But you keep
ridiculous
saying
questions.
that level, it would drop more from level.
These are elevations. Those are levels. Elevations. See what it says on the
Yeah, I
the
see
side there?
I'm
Pad
looking at it right now.
elevation, not pad horizontal. Pad elevation.
Mhm.
Those are elevations.
So I'm asking you, I'll ask again, because I've asked it probably 6 times already. But if I'm looking out horizontally from an instrument, is level going to be above that crosshairs or below the crosshairs?
Well, as Bev showed us, level is going to be below the crosshairs.
Okay, so you're saying that the level drops below horizontal, right?
It always
I just
does.
want to be clear. Huh?
It always does, yes.
I like how you put the qualifiers in there like that. Always does. Well, you say it does.
Okay,
and I'll
it does.
agree that you always say it does, but does.
Okay, it
Anyways,
does.
so
Well, all right, I retract always. It does, Mobius. How's that? You like that better?
it's not different. Anyways,
Oh, now,
so
no matter how I answer it, I'm wrong, right? Okay, thank you.
so the water level, the level will drop away from the horizontal. That's what you're saying?
Yes, it does.
So there's no hump?
Hump?
Yeah, there's no rise
No,
in
of course
elevation,
not. Of course
the
not.
water level?
No, of course not. Why would it?
I agree it wouldn't. I don't think it would
Why
rise.
would it? Horizontal is a tangent at that point. A curve always has to drop away from that tangent point. Always.
I know you like
That's
to
geometry.
intermix the two terms, horizontal and tangent. And I know that is like inherent in your model. But it always draws me back to a plane being made up of at least 3 coplanar points. And each point has a perpendicularity to it, right? There's a perpendicular relationship within that entire plane. How can you determine where vertical is if vertical is only at one point of that horizontal plane?
You have to know the point of tangency of the plane. That's all. That's simple.
Okay. So speaking of simple, let's, if we can, go back to
And a water level, by the way,
a
doesn't
straight
establish
wall.
a plane. By the way,
Let's say we're
a
going to
water
put
level. Just a moment.
carpenter's level.
Let's be clear about something too. A water level cannot establish a plane.
What?
With just 2 points.
People do it all the time. What do you?
With just two.
What are you
No, just pay attention. Just
You
with
move
2
it.
points, you've got 2 endpoints of a water level. That's the water level we're talking about. Just those 2 points.
Yeah,
That does
you
not
move it.
establish. That does not establish a plane. That could establish a line, if at best,
You move.
and an infinite number of planes that rotate around that line. Now you move the water level to another point, and okay, if you take the first point you were at and move the water level to another point, Now you have 3 points that will establish a plane.
Mhm.
But if you move that water level again, you have just generated another plane, a different plane, not one that is parallel to
Whoa,
the
whoa,
one
whoa,
that you
whoa.
just
If you
made.
move it again,
Yeah.
move what? What
Move
exactly
your
are you
water
talking
level,
about?
the water level.
Okay, so like you have one point that's stationary. You
Okay.
fix it to a post,
Got
right? That water level is right there. You've got your other end of the tube.
it. Okay.
You set it up. They're even. You make your mark.
Yep.
You put your thumb at the end of the tube so that there's no like air disturbances and stuff like that. You get a quicker, more accurate read after you move that end that you've got your thumb on to another location, another post. You take your thumb off, it bounces a little bit, it settles, you make your mark. You put your thumb on there, you walk to another post. You can build a deck with 4 posts, a deck, a horizontal, perfectly level deck using this technique.
Yes, I agree with that. You can.
Okay, so you can establish a horizontal plane
But
with a water level.
you've established at least 2 different horizontal planes doing that.
4 points
You've
all
established at least
on the same
2.
plane.
No, 2
Yeah.
different. You've established at least 2 different planes when you do
It's
that.
one deck.
It's
One
a
deck.
deck. It's only a deck, Mobius. Do you know how big
One
the
deck.
Earth is?
It's one deck.
Has anybody told you how big the Earth is?
One deck.
Yeah,
We're talking about we're talking about basic principles here.
Absolutely.
I don't know
it's a
why
deck.
you want to go into the imagination
It's a deck.
when we're talking about a
okay.
deck. You're saying 2 planes. I'm saying it's one deck.
All right, let's make the deck about 10 miles on each side. Can we do
Let's
that?
just make it whatever. I'm talking about the basic principles
Okay,
involved
I
in
am too.
making it.
I am too.
And where are your fundamentals based on?
I am too. Let's talk about let's talk
Are your
about
fundamentals based in imaginary?
let's talk about this
Or
10
are
mile by
are your
10 mile
fundamentals
deck.
based on practical application?
It's based on practical application and everything we can observe in
So
nature.
so show me a 10-mile wide, 10-mile long deck. Show me one anywhere. Point to it on Google Earth. I'll look it up right now. I asked you to be practical, Blue.
I'm trying to be practical. I've shown you.
So why are you asking me to imagine
shown
a
you
10-mile long deck?
Well, why are we going down this road? I've already shown you the.
Because I'm trying to establish
I've
fundamental
already shown
principles.
you the drop from horizontal using Bev's photograph. What's the problem with that?
Me drop.
Yes, absolutely
You,
did.
you-
100
you-
feet.
you explained your interpretation.
100 feet of it.
You didn't show me shit.
Then give
you
me
explained your
another interpretation. Tell me another
I'm asking you to
interpretation.
stick. I'm asking you to stick with basic principles.
I'm not going to
If you
go
can't do
anywhere
that-
else. Listen, until you explain to me, give me another explanation for why Bev's photograph shows what it shows, and we're not going any further until you do that.
What is this a cop out? Because I'm not Bev. You were on Bev's or over at the Discord talking to Bev the other day. I was not in that conversation. I listened to it. I was able to hear it, but I wasn't part of that conversation.
I showed you a picture that clearly shows a drop from horizontal. Now, I want your explanation for why that happens. If it is not Earth curvature, what is doing it?
I'm gonna say this again. I've repeated it over and over again already, but I'll say it one more time. And if you're not happy with it, then if you want to leave, that's up to you. You explained your interpretation of an observation. Period. End of story. I don't know why you came up with that interpretation. It's not me to it's not on me to determine an interpretation that you have. I'm not going to argue with your interpretation because
Well,
I'm not trying to argue opinions about shit.
Give me another one then.
I'm trying to talk about basic fundamental principles.
Again, so give me another explanation.
Okay, so
for why
this water
something
level,
in the distance drops 100 feet. Just tell me why. Why would I be able to look through? And it's not just that picture. It's lots and lots and lots of them. But why can we look at an object in the distance and clearly it is below this horizontal that you talk about? Why
Well,
can we do that?
I
Why
don't
do
know.
we always see
Why don't you
that?
ask George why he's got a picture of a level above the crosshairs?
Because he was trying to show that. That's why. He was trying to
Okay.
show why you don't make those kinds of observations at sunset. That's why.
So, okay. Well, I don't know what to tell you. That explains everything. There's really nothing else to say. I mean,
That was an entire video
you're
done.
telling me that it can't happen because, you know, somebody went out and made a video about how this is why you don't do this. Well, no shit. You don't take long distance uh measurements over water. How can you establish a horizontal over long distances over water optically?
You're saying that's not what you're.
I'm saying that George proved that and I'm using that word very strictly, proved that you don't do that, right?
Yeah, George proved that there are certain times of the day when you don't need to be taking observations.
Like any time of the day, those kind of observations are unreliable for accuracy. I mean, come on, Blue, you're an engineer.
Well, Mobius, when you do a video to try to show people what the dangers are
Sorry,
in making
retired engineer.
observations late in the afternoon or at night, it becomes even worse. You're very likely going to get yourself into a situation with lots and lots of refraction, especially over a surface like he had. And I don't disagree with any of that. That was the purpose of him doing that. Now, is that what you're claiming has happened at Blackpool? Because the problem with
I don't know
that
what happened
is
at Blackpool.
the problem with that is it dropped. It didn't rise up. He showed it rising up, not dropping down. There's no refraction that's going to push it down that far.
Well, I think it's weird that his feet were rising up.
His feet were rising up. Whose feet?
In the frame, because I mean we're talking about a picture, a flat image, right? Like,
No, we're talking about Blackpool. We're talking about
oh,
the
I thought we
roof.
were talking about a picture
We're talking about the
that you were
roof of
referring to.
the roof of
What about
Blackpool.
Blackpool? I've never been there, but
Oh, now you
what
don't know
about it?
anything about this, huh? Okay.
No, what are you talking about? I thought we were talking about a picture that you were talking about before, and I said, oh, well, his feet look like they're rising up in the frame, and you're like, what are you talking about? We're talking about Blackpool. Oh, okay, well,
What
what about
feet?
Blackpool?
His feet are rising up in the. What feet? Whose feet?
The frame, the picture, right? The picture frame. You know what a picture
No,
is, right?
I don't know what you're talking about. I have no idea. You
I thought we were talking about a picture.
It's getting uncomfortable for you now, I think. What are you talking? What frame?
For
What
me,
picture are you talking about? I have no idea
I'm
now.
talking about the picture that you were talking about. You
I'm
said
talking about
that
the
Bev
picture of
put
Blackpool
up
Tower. Yeah, Blackpool Tower
a picture of it.
through an auto level.
So a picture of Blackpool Tower through an auto level.
Yeah.
Why not just say that? That's what I've been saying. You're talking about a picture, right?
That's the only thing I've talked about is that photograph
Okay,
that was made, that picture that was made
photograph picture,
through the eyepiece of
right?
an auto level, showing Bev in the somewhat foreground and Blackpool Tower in the background. That's the picture I'm talking about. Is that
Right.
clear enough? Is there any misunderstanding now?
No, just
Are
so
we
long as
clear?
when I say picture, you're not acting like, what are you talking about? We're talking
Are
about
we
Blackpool.
are we clear?
Yes, we're clear. We're talking about a picture with Bev in the
Okay.
picture,
Okay. Now,
Blackpool in the background,
yeah,
right? It's a picture.
and the crosshairs are striking the
Right.
building at Blackpool 100 feet above sea level. Tell me why that's happening.
So in a picture, it's got a frame, right? Like with the boundaries of that picture. What's funny?
Uh, okay. All right.
Do you not know what I'm talking about?
Keep going. Let's see where this Gish Gallop's headed. Go for it.
All I'm saying is that his feet are rising in the frame of the picture.
His feet, Bev's feet. I'm not talking about Bev. I'm talking about where the crosshairs are striking the building at Blackpool. I don't
So
care what's happening with
the
Bev.
things above the crosshairs drop, and the things below the crosshairs rise.
I don't see Bev's feet. I don't see anything rising. It's a picture. What are you talking
In the
about?
frame. In the frame of the picture.
In the frame of the picture. What are you talking
Yeah,
about?
like if you're watching a movie of somebody walking away from the camera,
Yeah.
in the frame, the feet are going upward, right? And the head is going downward. And right? Do you know what I'm talking about?
I don't
follow
know
me
where
or
you're
what?
trying to go with this, but oh
You don't
boy,
know where I'm going with
I
this.
have no idea where you're trying to take this. So yeah, just keep going. This is
Well,
fun.
you're
I'm
you're
enjoying
saying
it.
the things are dropping down above the crosshairs are dropping down, and I'm
I'm
telling
saying
you, well, things that are below the crosshairs are going up. So what did you want to
is
know
it?
about the picture?
What is it that you don't understand about this? Should I get that picture out and we take a
I don't
look at it?
understand what
Why don't
you're
we do
trying to
that?
get at.
That's a real good idea.
That's why I'm asking you. I'm
Let's
asking
see.
you to get at what you're getting at because
Let's see.
I'm unclear what you're trying to say.
Let's see. Hang on. Let me find it. Let's see if I can open this one up. Now, hopefully that'll still, I don't know if it'll be sharing or not. Tell me if you're seeing Blackpool or not. I may have to stop and reshare.
I'm still seeing the LIGO Hanford
Okay.
graph.
Let's see. Stop streaming. And now let me go back again to this one. Here we go. And now you should be seeing Blackpool Tower. Let me get over to the picture in question. This one.
Oh, hey, this is that same presentation that you used, right?
Yeah.
Oh, can you? I
This
don't know
one.
if it's forward or backward, but real quick, can I just see if you have it on this still? There's an image where it shows I don't know, some instrument, and it shows the horizontal reference.
Hang on. That one?
No, maybe the next one.
Well, let's go back one more then and see. That one?
No, it's like a regular something.
That one?
Oh yeah, that one. That one to the left, right there.
Okay.
You see where it says principle of differential leveling?
Yep. Mm-hmm.
Help me understand how you process this in your mind, because I'm reading it. I'm seeing it says differential leveling provides a means of accurately measuring height differences between between points some tens of meters apart. A level is set up on a tripod and leveled so that the line of sight is horizontal.
Yeah.
In each of those leveling rods are plumb.
Right.
And perpendicular to that horizontal line.
Yeah.
Which is established by the level.
Yeah.
Okay. All right. I just wanted to be clear on that. We can go back to that picture if you want.
Yeah, that's what they depict, and of course, over tens of meters, you would never detect. You'd never be able to really detect any deviation from vertical between two rods that close together.
Never be able to detect it. Okay, got it.
Of course,
let's
you
go
wouldn't.
back to that picture.
And they go ahead and explain all of that, but let's see. I wanted to get to something.
Well, you already said that you would never be able to detect it, so that's fine.
But that's a follow on to it where they talk about.
Is that the part that they would never be able to detect, or is that something else?
Yeah, people talked about this because they exaggerate the drawing so that in actuality, if that was to scale, this auto level would be thousands of miles away from that rod. Okay,
I mean, that would be a ridiculous.
literally thousands, but it's just a depiction. But what's interesting is for
So
sight
which
lengths.
part is the actual?
This part's the part that's interesting.
Yeah.
For a sight level of 100 meters, the effect is only 1 millimeter. As with collimation error, the effect is eliminated by using equal sight lengths for foresights and backsights. That's how differential leveling works. And that's why we do it.
Over what?
And that's why we do it.
What was it?
We do.
1 millimeter over 100 meters?
Yeah. That's all Earth curve would do over 100 meters is a millimeter or less.
So how did they come up with that number?
How do they come up with that? Well, you can calculate
that
it,
ratio.
number one, but you can measure it too.
Well, that's what I'm asking, how they measured. Obviously you can calculate it, right?
Yeah. But you could easily measure
it. Prescribed with prescribed values.
Which you guys could actually do.
Let's talk about basics.
What you guys could actually do with Bev's test, with his realizing Euclid bullshit. You could do the same thing.
You can mute that anytime, right?
Yeah, I know. I haven't done that though.
No, I know, but I feel like when I'm trying to say something, you start talking again, and then it's just both of us talking over each other. So instead of, allowing me to speak, you can always mute me and say your piece.
No, I don't want to do that.
So that what you're saying will be clear for all the listeners. Did you want to go back to that? I thought we were talking about that picture still.
You want to go back to that?
Well, I wanted to ask you how they measure it. That 1 meter or 1 millimeter over 100 meters, like you said that they calculate. I said, yeah, within, prescribed values. Obviously you can calculate whatever within prescribed values, but how do they get the value in the first place? Like how do they measure it? How do they measure that 1 millimeter over 100 meter difference?
Well, we have
the dotted line. Sorry. Go ahead.
We've told you guys, I don't know, a few thousand times now, that it would be quite easy for Bev to do this with his realizing Euclid test. You could do this. You could use a water level, and you could use a theodolite, and you could line the water, you could put a tap in the center of it, and you could actually measure this. You actually can.
What, 1 millimeter?
Or you could actually do it with a single water level without a tap in it.
It says you could see that difference. Can you blow it up a little bit? Oh, it looks kind of blurry. Yeah. I don't know. Just to the right there where it says refraction.
Oh, refraction. Okay.
Yeah. See where it says it's got the dotted line and then it's got the actual reading?
Yeah.
So the actual reading, is that what you're seeing through the scope?
Yeah.
Then how do you know where that dotted line goes?
That dotted line is the horizontal that's been established by the auto level itself.
But the auto level is reading by the prism, where it says the actual reading.
Mm-hmm.
And the desired reading is, the elevation, the equal elevation from the instrument, it looks like right there, right?
That's because of refraction. Refraction raises.
So
actually helps you guys out.
So I'm asking you, how do you determine where that dotted line is so that you know that difference from the dotted line to the actual reading, so that you know that your actual reading is lower than the horizontal established at the instrument?
How do you know where the How do you know where the dotted line is? Mobius.
Yeah.
That's established at the level itself.
So, but if you're looking out through the level itself, are you seeing where the dotted line touches that stick, or are you seeing where it says actual read?
You see here on
that's
this
not
side.
Over 100 meters though. The other one was 100 meters.
This is over 100 meters.
Where's the dotted line in that one?
It's this line right here. That's your actual reading. You'll actually see that. You really would want to see this, which would be the same elevation above that surface, but you don't.
So S is 100 meters there. What about the other picture? It said S. Was it? No, it didn't say S.
It doesn't say anything.
What's it say there? So what's that say? What's the difference there?
Same.
The variable density of the Earth's atmosphere causes. You keep moving that thing.
Okay, I'm sorry.
Variable density of the Earth's atmosphere causes the bending of the ray from the staff to the level. The effect is illustrated in the sketch below. So how do you know where horizontal is if it's somewhere above the actual read, like what you're reading?
How do you know what horizontal is? It's that line. It's the same line. This line, actual reading.
Well, it's depicted differently.
Over
like the
here
same thing is depicted differently in the two images.
Yeah, it's depicted differently because it's
so how do you know that you're
because it's depicting refraction.
But how do you know on the stick? How do you know on the stick, like if it's accurate or not? Because your actual read could be different than the horizontal, or it could be the same.
It is going to be. Yeah, it is going to be because of refraction.
Well, the other picture depicted it as the same as the horizontal.
Well, I'm sorry. I'm sorry that these thoughtless bastards decided to break it up into three sections for you, but they did. Okay. And for the same reason that differential leveling eliminates the curvature problem. It also eliminates refraction if you have foresights and backsights, as well as collimation errors.
Yeah. Is that what that is up there on the top left, the collimation error?
That's the collimation error, yeah. And if you do equal foresights and backsights, you eliminate collimation error.
Is that with the theodolite or is that with the
that's just an auto level. Or it could be a theodolite. It could be either one. Wouldn't really matter.
So what's that say? Over 50 meters, the effect is 5 millimeters. If the sight lengths for backsight and foresight are equal, the linear effect is the same for both readings. Oh, that's a big difference over 50 meters. 5 millimeters. Well, so you're going to be 5 millimeters off from horizontal.
They're giving you an example, Mobius.
Would you be reading above horizontal or below horizontal?
It could be either way, couldn't it? It's collimation error. That could be above or below, either way, couldn't it?
That would be really confusing. Like, how do you know which one's the horizontal?
It's just an example that they give you, and they count on the.
I'm just asking, like in real
maybe
world.
Maybe you've got a little experience to go along with it, but if you don't, for a typical collimation error of 20 seconds, over a sight length of 50 meters, the effect is 5 millimeters. They're just making an example for you. What if the collimation error is 0? Then there's no error.
But how would you know if it's 0 or not?
How would you know if it's 0 or not? I got to think about that for a second. But this is one of the reasons why guys do differential leveling.
No,
when you do
I understand.
That, you don't have to worry about it.
I understand that, and like I said earlier, this is what I was getting at. You obviously understand how differential leveling works in the process. So asking me to explain it step by step was just ridiculous. But anyway, you want to go back to your picture? Or I don't know. Are you done with these?
The there we go. There's the picture. Now, Bev objected because this picture, this came from Shaky, by the way. I didn't put that in there, but
Shaky is awesome. He actually has a lot of really great pictures. Did you see his horizontal, his parallel horizontal picture?
No, I don't think so.
Yeah, he's got a great example of parallel horizontals, which incidentally also show verticals perpendicular at every point along those parallel horizontals. It's really spectacular. You should. Well, did you
I,
leave on the level, or are you still there? I know you
uh,
left Geos, right? I guess
I'm still
you had
over
some
there.
drama or something.
I'm still
Anyway,
I'm still in Bez for the moment, but I'll probably be leaving. Uh, that's the picture that we're talking about, and that's the question I've been asking you. You can see the through the auto level there's a horizontal crosshair. I've got that white line stuck on top of it, but it's right there. You can see it right at about the top of Bev's head, and there's a point on the tower, on the actual Blackpool Tower itself, which I used actually. If you go into Google Earth, you can actually get some elevations. I realize that that's not the most accurate way of doing it, and I'm looking for an actual drawing of the tower. But
you know what?
bas-
I don't have it handy right here, but I did put some models in Blender with with Google Earth values of various things. It was pretty interesting.
yeah, I wouldn't count on those elevations being any closer than maybe 5 meters, but something like that. But they're probably that close. At any rate, and that makes sense because the top of this 440 feet above sea level makes sense because the top of that flagpole up there is 519. So you can work out all these ratios and say, well, okay, that's about 440. And the top of this building is also very easy to pull off, which is the roof of this thing over here, is also easy to pull off. And the crosshair is sitting right on the roof of the building, which is about 100 feet above sea level. Now, clearly, it sits right on the beach, basically. Down here is the beach level. You could say Bev's elevation is somewhere in there. I don't know where exactly. But still, that crosshair is parked 100 feet above sea level, more or less. How can that be?
How can
And you,
the tower be 400 feet above sea level?
how can the roof of that building be 100 feet above 100 feet above sea level? But this auto level is showing level to be right at the top of that roof. How can that be?
Well, I guess it's the same reason, the same way Bev's feet are at the bottom stadia and his head is at the middle stadia or at the crosshairs. And then the top stadia, I mean, it shows him being 400 feet.
Huh?
It's a image. It's a flat image.
What do you
You're
mean it
gonna you're gonna
shows
give
400
you're
feet?
gonna
What are you
give
talking about 400 feet?
values to something that
No,
what's that?
what are you talking about 400 feet? What?
Bev's feet are at the lower stadia right there.
What's Bev's height?
I don't know how tall he is. I know he's not 300 feet.
Of course not. We need to know what Bev's height is, and the distance uh, is roughly half of the stadia distance here, the stadia interval. So it's roughly half of that. Let's say from that stadium tick there up to the center, up to the line here, because that's right at the top of his head. Let's say that distance is 5 feet, right? 5 feet. Now, multiply 5 feet times 100, that's 500 feet. Multiply times 2, because you're only using half of the interval. That's 1,000 feet. Bev was about 1,000 feet away
From what?
from the instrument.
Mhm.
That's how you use stadia. That's how it works.
To measure the distance.
Yeah, it's a stadiometric distance measurement.
Yeah. I did that with my auto level. It was kind of weird because it gave I took a tape measure to double check and it was off at a fairly short distance, which was surprising because I thought that it would be more accurate at a shorter distance. But was off quite a bit.
I don't know. This seemed to make sense. If that's 340 feet
I'm just
times
saying that,
times
you know,
200, here we go. 340 feet from this point, which is the horizontal, to that upper stadia tick. That distance at the tower is 340 feet.
here's my
Times
contention about
times
this.
100 times
Okay,
2
go ahead.
is
Like I said, you can
68.
mute me anytime.
Times 100 times 2, that's 68,000 divided by 5280 is 12.9 miles. Bev said his auto level was set up at about 13 miles away, so it absolutely works.
Yeah, I'm not saying that that it doesn't work. I'm not saying that it does work. I'm just saying that my contention is that sometimes it works, sometimes it doesn't work. Sometimes it's accurate, sometimes it's not accurate.
Well,
So
these things are used all the time.
so what are you looking at here that I should be in awe about?
Well, what it shows you is that the building has dropped by something like 95 feet, assuming
The
that
building dropped.
it had to, assuming that
How did it?
assuming that the auto level is sitting at about a 5 foot elevation, and its center line of its crosshair in that over that distance is now up at 100 foot elevation. That
I
means
thought
that
you were
this
just
that
measuring
means
the distance.
that means that point on the tower has dropped 95 feet. How did that happen? Why
Are you
is
saying
this
that?
why
Are
is
you
this
saying that you have?
horizontal line not down there 5 feet off this beach level?
Wait a minute. Are you saying that this is an established horizontal?
That's what an auto level does.
It, it,
It establishes a
you can look through
horizontal
it when it's
plane of
not
reference.
horizontal.
It's a
You know
horizontal
that,
plane
right?
of reference. Well, so that was a question I asked Bev. Did you miss it? Did you fail to set the auto level up properly? Is it not adjusted correctly? Is that the
Oh,
explanation?
I wouldn't be able to speak for Bev, but I can see Bev's not at the auto level in that picture.
Yeah, he's not. That's right. Somebody else is making the picture.
And
But my question
I
is,
mean,
whoever
I'm
set it
just
up here?
saying,
That's a real question.
yeah.
Whoever set the fucking thing up? Did they set it up correctly or not? If it's
I don't
not,
know.
if it's not
You're
set up
asking me about
properly,
a
then
picture
yeah,
that I wasn't even there, and you're asking me what Bev did. Well, Bev's in the picture, so and you're using this as proof for something, or I'm sorry, evidence.
that's evidence that of Earth curvature. Yes, it is.
So
Absolutely,
it's so
absolutely.
far the only evidence that I heard is that it's evidence of how tall that tower is and how far away you are from the
Okay,
tower.
okay.
I haven't
I,
because you're using the stadia as a distance measuring. You're not using the stadia
no, 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 no,
as
no,
an
no, no,
elevation
no, no.
measurement
Hang on a second.
or
Hang on.
as a
Hold the phone. I'm not
yeah. Go
doing
ahead.
that at all. I'm not doing that at all. I'm just showing you
So where's the
that
horizontal?
I'm just showing you that the stadia marks comport with and agree with what Bev said his known distance away was. That's all. That's not part
That's
of it.
it.
That's just a way to show you
Okay.
that the auto level is accurately representing what it's seeing off in the distance in terms of its ability to
To
give you
measure distance.
to give you a stadiometric distance.
Right.
That's right.
That would be like a horizontal distance from
Yeah,
the
horizontal distance. But the
right.
point is this: that's what we see. That's what you ought to see. Why don't you?
Odyssey. What do you mean Odyssey?
Do you agree that the auto level is sitting on a beach?
Well, it looks like it's in sand. I would assume
Okay.
that it's at the beach.
Yeah. Do
There's
you
the
agree?
ocean right there. It's an oceanside
Do you
park.
agree? Yeah. Do you agree there's an ocean that's running parallel to Bev here, uh, all up this left side where I don't know where it is, but there's the
Parallel.
ocean. There's the ocean.
Yep.
Okay.
Yep.
And the auto level is only 5 feet above that above this beach. So
don't
call
know
it
how-
whatever you want to call it. I mean, however how
I
you
mean, the
want to
thing
say
could
it
be
is.
sitting on the ground. I don't know how tall the auto level is
Well,
just
okay,
by looking
all
at
right,
this picture.
yeah. Hey,
If you've got extra information, then please share it. So far, I'm not hearing any information as far as the auto level, like how it's set up, if it's even establishing a horizontal. You
well,
can look through the an auto level without it being level. It's not like it turns black, right? It's not digital or anything.
well, Bev didn't contest any of this, so I don't know. Have a
Did he
word with him.
confirm any of it?
Did he confirm any of it? Yeah, absolutely.
What did he confirm? That he's in the picture?
Confirmed he was 13 miles away from the tower. He confirmed
So he
that,
confirmed the distance that you can tell with the stadia measurement.
yeah.
Okay. What's that got to do with any
Can you
curvature
not
or
see
drop from horizontal?
You can't see the top of that building, and you can't
I can see
understand
the
what the
top of the
problem
building.
is, huh? If that thing is
Why don't you
establishing a
spell it out?
horizontal, if that thing is establishing a horizontal plane of reference,
It's a big if. I mean, your whole argument depends on that if. So,
well, okay,
do
all
you
right.
have an
So
answer to it?
I see where this goes. All right, no problem.
I'm just trying to ask you to be
I
honest.
see where this goes. I'm asking you to be honest, for God's sakes.
I am honestly telling
you're
you,
looking
I
at a
cannot
picture.
confirm nor
You're
deny
looking at a
if that auto level
picture.
is horizontal.
You're looking at
If you want me to lie, I don't know what you're asking me.
Okay, let's make this assumption then. Let's assume the auto level is adjusted properly. Let's say that the auto level actually has been set up the way it should be.
Oh my God!
What would
so
in
now
that
we're going to
case?
assume so that
in
you
that-
can get your way.
In that case, what would that picture tell you? Let's see how honest you're willing to be.
In what case?
If the auto level is set up correctly, what would that picture tell you about the tower in the distance?
Really wouldn't tell me anything because I mean you can't measure anything. You can't even see the rod. You can barely make out that he's got anything in his hand. You're trying to equate
The
where
rod's
these
not part of
crosshairs
this.
line up
Yeah.
under the assumption that the auto level is set horizontally.
Okay, so your claim is the auto level's not set up properly. Your claim
No,
is
my claim
that the
my claim
elevations
is
at
that I don't
LIGO
know.
can't be trusted.
Why don't you get
Your
my
claim
fucking
is
claim right?
you don't have a fucking clue what
Why
you're
don't
talking
you get
about.
my claim
That's
right
what your
before
claim
you tell
really
me what
is,
my
right?
claim is? If you don't want to play honest, then just let me know.
Hey, you've been nothing but dishonest since you got in here, Mobius. Don't
How
start
so?
that
By
bullshit
telling the
with me.
truth?
You're not telling the truth. There's
You're
nothing
telling
truthful
me
about
that
it.
I
I
you're
asked
telling
you
me
a
that I know
I asked
how
you a
that auto
specific
level was set
question.
up?
I asked you a specific
Oh my God, Lou.
hypothetical,
Come on,
and
dude.
you won't even answer it.
I hope
You're
got a
not
better
even
argument
honest
than
enough
this.
to answer that, Mobius.
I hope you
I
got a
said,
better
make the
argument
assumption
than-
that the I'll try it again.
I hope you
Make
got a
the
better
assumption
argument
that the
than
auto
this.
level is set up correctly. Make
You
that
don't have to
assumption,
get all
and then
upset.
tell me what that picture would tell you. And you're not even
Would
honest
tell me?
enough to say that.
You want me to tell you what
You
that
won't even do
picture
that.
would tell me
Yeah.
under the assumption?
Are you not capable
Well,
of assuming anything, Mobius?
I prefer
You assume
not
that I'm
to,
wrong.
honestly.
You don't have
want
any
me to- you want
problem
me to-
assuming that. Why
Yeah.
can't you
want me to be
assume that the
honest?
auto level is level? Huh?
You want me to be honest?
Yeah.
I have a problem relying on assumptions. I'm not going to make any claims based on an assumption. That's just fucking stupid. If you want me to, if you're demanding that I make a claim based on an assumption, just so
I'm
that
not
you
asking
can say,
you to make a claim.
I'm right.
I'm asking you to
I
tell
don't-
me what
I
that
don't
would
think that's
tell you.
honest.
Okay.
Well, if you want to keep being dishonest, that's up to you. I don't
Look,
care.
stop it, Mobius. I'm not being dishonest. You're the one being dishonest.
You're telling me
Now, look,
to rely on an
I have
assumption
asked you-
to
I've asked
make
you a
an
simple
interpretation.
question. If
telling me to
if
make
the
an
assu-
interpretation
I've
based
asked
on
you
an
to make an
assumption.
assumption
Oh
and
my
then tell
God.
me what that would tell you. Can you not do that? I realize you're caught here.
I'm not caught with anything.
Oh yeah,
How am I going to give you any,
You're
any
right in the corner.
information based on an
and you're desperate to
an
find a way out, and it's not
interpretation
going to happen. I'm
off
not
of an
letting you out of the
assumption?
corner.
Are you hearing me?
Yeah, I'm hearing you.
Are you hearing me ask you how I'm going to give you any information from an interpretation based on an assumption? I'm asking you, honestly, do you expect some real information from that?
I expect an honest opinion. I expect an honest answer, and you're
Are
not
we
capable
arguing
of doing that.
opinions? Is that what we're doing? We're
You're
talking
not
about opinions?
I'm asking you to tell me
Oh
what
my
this picture
God.
would tell you
I thought
if the
that,
auto level is level.
sorry,
You
Blue,
haven't
I had
proven
higher
that it's
hopes for this
not.
conversation, man.
I did too, Mobius. But you've
I
done
did
nothing but
not
run
know.
from the question from the beginning.
I did
Are
not
the
know
elevations at LIGO
that you're
accurate or are
going
they
to
not?
require me to imagine shit that isn't real so that I can make assumptions based on it.
Are you can't answer even the simplest of questions with any honesty whatsoever, Mobius. Are the elevations at LIGO accurate or not? You refuse to answer that.
If Santa is real,
if the
I
auto level
might get presents this Christmas.
if the
I
auto
don't know.
if the auto level is set up properly, and I would make the assumption it is because Bev claims to have a certificate. I would claim that you are being dishonest by not telling me what that picture tells you. That's what I would claim.
Well, I know what you would claim, and I know why you would claim it.
I don't care what you don't know what I'm claiming.
I know exactly what you're claiming. You're claiming that this picture tells you some information. And you've got all these calculations next to it. Look at all these numbers, all these different calculations you got next to it. You've put a lot of thought and effort into this picture. I mean, my God,
A lot
dude,
of thought. Took me about 3 minutes.
I don't care how long it took you. You put effort into this.
Yeah.
I mean, you're using this as like, I got it. This is me winning. It's just hilarious. I
Yeah.
don't know.
This is me mopping the floor with you.
Is it
Yes, it is.
your picture with
You have
no
failed.
information?
You have failed miserably. Well,
How
maybe you
so?
ought to tell your boss to stop posting pictures that aren't correct.
Boss.
Yeah, Bev.
Bev isn't my boss.
Your mentor.
He's not my mentor. We're friends online. I don't know what kind of thing you got going on over at your place, but this is not that kind of atmosphere.
Okay, so I don't think there's any point in going a lot further with this, Mobius. You're not going to be honest about what you're looking at. You're not going to give me a straight answer about anything. You're just going to play for the rest of the afternoon. And I've got better things to do with my time.
Me too. I wasn't planning on talking about some picture that you want to, hang your hat on. I thought we were going to talk about LIGO, but I just wanted
Well,
to
we've been
get
talking
some.
about LIGO, and you won't talk about it. You won't.
I wanted to get some. I wanted to get some basic, understanding, some common ground on basic fundamentals before we ventured out into making, wild claims and shit. But whatever.
Nobody's calling
It is what it is.
Are you calling this a wild? You still calling this a wild claim?
No.
You're still saying that blue line is a wild claim?
No.
You're still questioning the accuracy of those elevations? Are you?
What I'm saying is that you are claiming that the fact that these elevation values, you're claiming that those aren't based on a hypothetical reference model. I'm claiming that they are based on a hypothetical reference model because that's what the documentation says that they're based on.
You were talking about a benchmark.
No, I'm
That's
talking
the
about
only thing.
I'm talking about the elevation data.
The
Right,
elevations are measured on the site, Mobius.
On
They're
the
not
site.
calculated, and they're not based on anything other than that starting elevation, the project
What do you mean
elevation
they're not calculated?
sheet. Huh?
What do you mean they're not calculated?
That blue line represents actual measured elevations, Mobius.
But measured how? You don't know how they were measured.
I gave you all the ways that they could have been measured. Which one
and
they
you're
selected,
saying,
I don't know. But you can do that any way you like. You could do it with a water level. That would be pretty stupid, but you could do it that way. You
and
could
you're
do it
saying
with
that
an auto
water would
level.
drop.
You could do it with an auto level if you wanted to. That would likewise be pretty stupid. I would choose
So
a
no
theodolite.
cord.
I
I
would
just want
choose
to
a
be clear
theodolite.
before you run off. I want to be clear. So no cord.
I'm not running
line,
anywhere,
right?
buddy.
Okay, good. So no cord line then, right?
What cord line? We're not talking about a cord line. These are elevations.
From one end to the other end, from 0 to 13,000 feet. If you took a water level and drew a straight line with that water level, it wouldn't be a cord cutting through a hump of water.
In this particular case, no, it wouldn't.
What would it be doing?
It would be a perfectly straight line.
Yeah, a
From
cord
one
is
end,
a straight line.
that pad would be a perfectly straight line.
A cord is
not
a straight
cord,
line.
not a cord, a perfectly straight line.
I'm sorry, are you saying that a cord in geometry is not a straight line?
No, I'm not saying that.
Okay, so a straight line then.
Yes.
A chord.
Are all straight lines chords?
No, but all chords are straight.
You're saying that all straight lines are chords, right? Let me just be sure that we got this right.
Straight.
You're saying that all chords are straight lines and all straight lines are chords.
For the fourth time,
that's what you're
all
saying.
All chords are straight is what I'm saying.
Well, yes,
why do you reverse what I'm saying to make it sound like something that I'm not saying? I'm clearly saying that all chords are straight, and you keep saying, so you're saying something totally opposite of what I'm saying. It's a weird tactic, Blue. You do it all the time.
Yeah, no, you seem to be confused here.
I don't know if you do it on purpose, if you were brought up that way or what, but it's just weird.
In this case, it is not cutting through any part of the earth because that thing is flat, straight.
What is this? The line between the 2 points?
The pad itself.
Oh, I thought we were talking about if we took a water level from 0 to 13,000 feet, if it would be a chord.
And I answered that 5 fucking times already.
You said
no, it wouldn't be a chord.
So what about Pontchartrain? I thought Pontchartrain, from one end of the Pontchartrain to the other end, there would be a chord with like 90 some feet of water above it.
Pontchartrain's not a straight line. Pontchartrain is following the curvature of the earth.
So if I took a water level,
Pontchartrain is an arc.
So
it is an arc segment, 24 feet, 24 miles long, and a chord line is applicable in that case because Pontchartrain is not straight. LIGO's pad is.
So let's examine this for a second, if you want. Would that be all right?
Examine what?
Well, let's examine the differences here because it's been brought up before. I'm sure your listeners would like to hear.
I'm waiting.
Don't you want to demolish me on this?
I'm waiting. Go ahead.
All right. So if I took a water level from one end of Pontchartrain to the other end of Pontchartrain Bridge.
Mm-hmm. Yeah.
Would that be a straight line from point to point?
If you only have 2 points and you connect them, the shortest distance would be a straight line, yes.
Okay. So in between those 2 points, would the bridge and the water in between be above that straight line or below that straight line?
Above that straight line. And they are, and the GPS data shows it.
Great. So there's a rise from that point, right, to the middle of that bridge.
Mm-hmm.
So you're at the middle of that bridge. Would you say it was like 90 feet?
Yeah, 90 feet.
Okay.
Close enough.
From New Orleans, it goes from New Orleans, right? Is it New Orleans or what's the town right there on the south side.
It's New Orleans, yes.
And then it goes to Melville
Yeah,
on the north.
yeah.
So at the New Orleans side, we've got a straight line from point to point, which would be 90 feet from the surface in the middle. So would you say that the surface, the water in between, goes up or down from that chord?
I believe I've already answered that.
It goes up, right? Just
I
so you
already
don't have to
answered it,
repeat
Mobius.
yourself.
I'm not going to repeat it. I've answered it once.
You're not even going to give me a simple yes.
Pay attention.
Or
Write
no?
it down next time. Yes,
Okay.
it goes up. Write it
Okay. Yes,
down,
it
okay?
goes up.
Don't
I
ask
did.
me again.
I drew an arrow and everything. All right.
Don't.
Good. All right. So from point to point, that water goes up. It doesn't drop down.
Yeah, that's right. Compared to that cord line, yes.
I thought earlier you said that the water would continuously drop down away from the line
That's not a
between
horizontal, is it? That's a
the
cord
two.
line.
Well, a water level establishes a horizontal.
Water level establishes 2 points of equal elevation, Mobius.
So if I have two ends of a water level,
Mm-hmm.
and I separate those two ends,
Yeah.
at what distance are they establishing a horizontal, and at what distance are they not establishing a horizontal?
That's a ridiculous question. Think of a better
Well,
question.
I would say that it always establishes a horizontal. I know you disagree with me, so I'm asking you to point out where you disagree. Like what's the point at which you disagree with what I said?
I haven't agreed with anything you said.
Earlier
Other
you
than
did.
if you connect the two ends of a water level with the shortest distance between them, you will have a straight line. That's all. And on the surface of the Earth, it won't be on the surface. It will be a chord.
Well, when we
It
were
will be
talking about
cutting through the
LIGO,
Earth. It will be cutting through the Earth. And if you
when we were
measure the
talking
height of the water along that chord line, you will see that it rises all the way to the center, and then it drops down again until you get to the other end of it.
how long is
That's what
Pontchartrain?
will
What is
happen.
that? 26
20,
miles?
24 miles.
24 miles.
And it rises
right.
about 90 feet. Now
How
you
long
can
is
do.
LIGO?
Now we can compare the same thing at LIGO. Let's say
4 miles?
at 2.5 miles.
2.5
Like
miles, right?
so, LIGO's
4
about
kilometers.
LIGO's about a tenth or so, something like that.
So a tenth of the distance, the water level would drop below that
LIGO is
that line.
LIGO is not a chord line. LIGO would be more like a tangent line.
Wait a minute.
And both ends will be above if you made it that if you constructed it that way. Both ends of LIGO would be at a higher elevation.
So
As it is
on my piece of paper in front of me right here, I got a profile picture of Pontchartrain with 2 points at either end. I got New Orleans, I got Melville,
okay.
and I've got a straight line in between them,
Yep.
and then I've got an arc
Yep.
with 90 feet rise in elevation in the middle.
Mm-hmm.
And then underneath that, I've got a drawing of LIGO of 2.5 miles. It's a straight line. And then I've got a water level at this point and a water level at this point. Sorry, at either end. I know you can't see what I'm drawing. And I take that water level and I take it from one point to the other point. And you said earlier that that water level would drop 4 feet from that horizontal.
You're mixing things up again, Mobius. This is just being dishonest and disingenuous. The
Well,
4 foot
no,
change
I'm
you're trying to compare a 4 foot change in elevation with that chord line at Pontchartrain. That's ridiculous.
Well, at Pontchartrain,
absolutely
the water level
ridiculous.
would go above. Like if I took that water level at halfway, let's say I went at, I don't know, 12 miles.
Have you noticed the shape of the curve?
If I went at 12 miles from with the water level, right? Where would that line be?
Huh?
The horizontal line established with the water level, where would that line be if I went 12 miles on Pontchartrain?
I don't know what you're asking. That question is broken. Try it again.
Well, earlier I took my water level from New Orleans to Melville, which is 24 miles. If I
Uh-huh.
took that same water level from New Orleans to Midway
Okay.
between,
Okay.
which is about 12 miles, right? Half of 24, simple
Yeah.
math.
Uh-huh.
Where would that line be between the two ends of the water level?
Between the two ends of the water level. Jesus Christ. How stupid can you be?
So you're going to answer my question with part of the question?
You just said you put the you just said you moved the two ends of the water level 12 miles apart. Now you want to ask where the ends of the water level would be. Jesus God.
No,
It's your
I'm asking
question.
you where the line
The line would be between the two
is.
ends of the water level, would it not?
Are you
How can you
saying that
not
it's no
you
longer
don't even
horizontal?
understand your own question.
Are you saying that it's no longer horizontal?
I never said it was horizontal to begin with.
So you're saying that
We're talking
a
about
water
chord
level.
lines. Now you've got a new
You're
chord
saying that
line.
hold on a
This
second.
time
You're saying that a water level
we've got
does
a
not.
now we've got a new chord line that's only 12 miles long. Why don't you ask me how high the water would be at the center of that chord line above it?
I'll wait till you're done thrashing.
I'd say about 21 feet.
So earlier you said that a water level establishes a horizontal, or do you?
I did not. Stop lying.
Okay. I thought that you said it. My bad. If you didn't say it, then fine. We will go on with you saying that it does not establish a horizontal.
It does not establish a horizontal.
So a water level,
A
according to
water level,
you,
I will say it
is
one more
not a
time.
tool to establish a horizontal plane of reference.
It
I
is
just want to make
absolute.
sure.
I'm going to say it again so that let me be very clear about this. A
Be
water level
very,
is not
very clear so
very,
that you're
very
not
clear. So
contradicting
clear that
yourself.
even you will be able to understand this.
Even
Pay
me.
attention.
Great.
Write this
Yep.
down. A
I'm
water
going to
level,
write it word for word.
write it down word for word. A water level is a
water
device. Got it? Water level is a device
is a device
that establishes
that
2 points
2 points
of equal elevation.
of equal elevation.
Got it.
Yep.
Now, try not to misquote me again.
That's blue. Right. Okay. So 2 points of equal elevation. What would you say that line is between those 2 points? Would you say it's a tangent? Would you say it's a chord? Would you say that it's a horizontal? Would you say that it's vertical? What label would you attribute to that statement?
You're asking me what I would call the line between those 2 points on that water
If you're building a
of a
deck
water level. Okay.
using a water level,
Okay.
because it establishes
2 points.
2 points of equal elevation, right?
Yeah. Right.
So if you're using that terminology that you just described what a water level does to build a deck, what would you say that deck is? Would you say that deck is horizontal? Would you say that it's
I'd say
tangent? Would you
that
say
deck
that it's
deck
level?
is a deck, and we don't usually get into geodesy when we're talking about a deck. That's what I would say.
If I built a deck with a bunch of posts randomly, like in the center of this deck, and I took that water level to each post anywhere in that vicinity of that deck,
Yeah.
right? anywhere within that parameter.
You seem to be hung up on decks here, but okay, keep going.
Well, because it's a horizontal. It's something that you can build in reality with a water level.
Well,
I'm just asking
a,
you.
a bridge at Pontchartrain is something we can measure in reality too.
Mm,
We
yeah.
don't seem to want to be talking about that anymore for some reason.
What, the 5.3 or 5.8 meters above the sea level
Yeah, that's what it's supposed to do.
consistently,
That is level.
except for like the humps and stuff.
Yeah, that's what it will do. It's level.
Yeah, I agree. And even elevation is level.
Yeah. It's the
Yeah.
definition of level. Unfortunately, when you draw that chord line between the two ends of it, the center of it is 90 feet above the chord line.
Why would I draw a chord line between the 2 points?
To see the curvature of the earth, of course.
Well, wait. I would draw a chord line
You would
between 2 points
assume a chord line.
so that I can.
Can you understand assuming that the way we do things in reality? I mean, real grown-up people. You can
Are you saying that grown-up people assume things?
You could assume that you could assume or imagine, if you want to use that word, or envision a line drawn between two ends of a water level. Can you not?
Mhm.
We're not going to do it in reality, obviously, but can you not see that there's a hypothetical, at least theoretical line connecting the 2 points of that ends of that water level?
Let me be very clear.
Yes or no?
I never disagreed that it's not hypothetical
Okay.
or theoretical. I've always maintained that your assumptions are hypothetical. So I'm not disagreeing with you.
My assumptions are hypothetical. In terms of what? I said the elevation of the bridge is level.
You need me to assume curvature so that I can draw a chord between 2 points.
No. You claim that you claim there's no difference.
Maybe I heard you wrong.
Yeah, maybe so. You're claiming that there's no difference between horizontal and level. That's what you guys always claim. Level is horizontal.
And I'm still trying to understand where
That's what you claim.
Find that different.
Because level is not horizontal.
And what is your justification for that statement?
Well, let's just use Lake Pontchartrain Bridge. That's as good as any.
Okay.
What about it? Use that. Measurements that we make on Pontchartrain Bridge clearly show that it is not a straight line. It is an arc segment. In fact,
why? Because it measures 5.8 meters above the sea level.
It is an arc segment of a sphere of a circle, which is 6,400,000 thereabouts meters, the radius of it. But I don't think you understand how GPS works.
I know what the model is.
That's getting off into something that you probably don't want to go into.
No, I don't mind. If you want to talk about GPS and all that technical stuff, we can. I know that it's based on a hypothetical model. It has to be.
Yet it returns that elevation. It returns that elevation perfectly, doesn't it?
It returns that elevation that's on that model.
No, the elevation you measure in reality. When you go out there and measure how high the bridge is above the damn water in Pontchartrain, it is consistently 5.8 meters all the way across, is it not? Except where the humps are.
Yeah, I mean, I've never been to Pontchartrain, but I would assume that, yeah, okay, you can stand off of the side there and put a tape measuring down, and on any given day you will get a consistent measurement. Maybe not 5.8 because sea level rises and lowers and stuff like that, right? Tides, shit.
Yep.
Right. So if you went on one day, you would most likely consistently get the same distance from the rail to the sea level.
Well, certainly in the length of time it takes to drive 24 miles, I don't think the sea level is going to change very much in that area, but maybe an inch or two. But yeah, it's very consistent. That's the elevation the true elevation that GPS returns. But here's the problem. The only way GPS can give you that elevation is by first taking the XYZ data, GPS data, for each point that it's measuring, and subtracting from that the height of the ellipsoid, and then correcting it for the geoid height at that point. Then and only then do you get the actual elevation of the bridge above the water.
The actual elevation.
Yeah, the elevation you could get taking your tape measure out there and sticking it down to the water.
Yeah. At what point did Jesse, who did this with his GPS, at what point did Jesse stop along the bridge to verify that? Did he ever? I don't know.
Well, I don't
I
think
never
so.
heard about him stopping and checking.
I don't think he did, and I don't really think there's any reason for him to want to. So what if it was off a
Except
foot?
to verify the information that he's
what if
receiving
it was
on
off
his GPS unit.
So what
that
if
might
it was
be
off a foot?
reason.
Well,
I
it
don't
was.
know.
Well,
Science.
Yeah.
You got to weigh your variables.
Yeah, right. I'd like to see.
I'm just saying.
Done.
Measure twice, cut once, right? Blue?
Yeah. Well, I know how you guys do it, Mobius. You measure with a micrometer, mark it with a crayon, and then cut it with a hatchet. That's what you do.
I knew you were going to get into some really colorful insults eventually.
Don't ask ridiculous questions like that. Of course, Jesse didn't stop out there in the middle of traffic on that damn bridge to drop a tape measure down to the friggin' water. What in the hell would possess you to even think a thing like that? Who cares if the elevation is off a foot or 2 feet? You've got a 90-foot sagitta in the middle of that thing. You're not going to get rid of the problem. You're not going to run from your problem by trying to make a measurement of the height of the damn water. That's crazy.
I don't have a problem. I'm glad that we were able to clarify that Jesse did not, because that would be a stupid thing to do.
Of course,
Stop
it would be
anywhere along there to verify that the unit he was using was giving him an accurate measurement.
How do you know what sea level is at that particular moment, sir?
Well, it could vary, right? Especially if there's waves. I mean, how are you gonna measure that? That's why it's a.
That's my question. How the hell do you think he's going to do that?
That's why it's put into a computer model.
Would he stop and measure?
Please tell me that. Put into a computer model.
What would he stop and measure? Let's say he stops in the middle of the bridge. Now, what do you want him to do? Measure to what? With what?
I don't want him to do anything. I don't care if he does anything.
You're asking why he didn't do it.
I'm just asking you what he did.
You're asking why he didn't do it. Tell me what he didn't. Tell me what he should have done.
He didn't check his variables.
I talk to him all the time. What do you want us to do the next time we do that? What would you like to have us do?
Oh, I don't care what he does. He can verify his readings, or he doesn't have to. He can just go on, whatever.
Well, we know for a fact that on average that bridge is around 5.8 meters above the surface, the water surface. We know that.
Whatever. That's
and it consistently measured that all the way across. Only now, when you go back to the original data, the XYZ data, that's what I used, and you plot those positions in free space, then the curve reveals itself. Then you see that those points are not collinear. They form an arc with a sagitta of about 90 feet. So please tell me how GPS managed to get the right elevation consistently all the way across that bridge, but still shows us a 90-foot sagitta when you use the XYZ data.
What do you mean the right elevation?
The correct elevation, I'll even back off and say the approximately correct elevation of the surface of the road above the water. It doesn't bounce around from 5.8 to 12.3 to 22 to -4. It is always between 5.5 and 5.9.
Why would it? It's built into the computation in the program.
It is receiving satellite data. It is receiving data from satellites and calculating a position in free space in XYZ coordinates. And only when you take the ellipsoid away from those points do you, and correct it for the geoid, do you get the elevations that are approximately what you expect above sea level.
So let me just get this straight. So you're saying that these are correct elevations, even though it would be stupid for Jesse to stop in the middle of traffic in that bridge to verify that the data that he's receiving in his GPS unit is what his real-time measurement is?
He knew before he left the shoreline what the
That's
reported
fucking convenient.
what the reported elevation of. In fact, I think I could probably pull that up right now from other sources. How high above the lake level is the surface of that bridge? I bet we can find it from another source. Now you want him to stop out there. There are places on the bridge you can
No,
stop.
I'm not asking him to
but
stop.
But you're questioning why he didn't stop to verify something.
No, I'm not asking him why he didn't.
And you can't even
I'm just
tell
asking
me
if he did or not.
You can't even tell me how he would have done that.
Slow down,
What are you
Scooter.
supposed to
I'm just
do?
asking if he did or not. I'm
What
not
are you supposed to
asking
do?
him to
What do you
anything.
think he ought to do? Stick a tape measure down there and let it waggle around in the water? Is that what you're asking?
No.
Is that what you think would have been a good?
Nope.
You think they would have verified something or the other? What is it you think, or do you know what you think? I'll take that as a no.
Are you done
All right.
thrashing?
All right.
I was asking if he did or not. I didn't ask him if he would. I didn't ask him, would you please? I didn't ask you if you would ask him to. I didn't ask him, why didn't you? I didn't ask him or you anything. I asked you if he did or not. And you confirmed that he didn't. That's all.
Okay.
You don't need to continue thrashing over it. It's just a yes or no. He didn't. Let's move on. Right. So what would you like to say about it? This 90-foot.
What would I like to say about it? It's there. It's measured. It's measurable. We can
So
get
there's
that.
a 90-foot measurable difference in elevation from the 2 points of that water level?
No.
So from the imaginary chord line that I'm drawing, assuming that there's curve, that's when I get the 90-foot
Yes.
difference. Got it.
That's what happens.
So the water in a water level does or does not drop away from the horizontal.
Now we're back to horizontals again.
We haven't left. This is all about establishing first principles, basic stuff.
Yeah, I agree with you. It's pretty basic.
If we can't agree on these basic principles, I mean, we're not going to see eye to eye on anything. So if you don't want me to agree with you and you're not willing to agree with me, I don't know why you had me on, to be honest.
Well, you're the one who asked for it.
I asked for what?
You asked for this. This wasn't my idea. This was yours. Now go ahead and lie about that. Yeah. You're the one that challenged me about LIGO. That was your challenge, not mine.
I may or may not have challenged you about LIGO, but I didn't want to have a conversation where we weren't trying to communicate with each other.
Good. Let's communicate.
Okay.
Are the elevations?
So I'm trying to find common ground.
Are the elevations at LIGO accurate or not? Are you disputing that? Because if you are, the conversation has to end at that point.
I'll tell you this one more time. I've said this I don't know how many times, maybe in different ways, but the elevation data, the values are based off a hypothetical reference model. Those
and that is a lie.
Values, that is not a lie.
It is a lie. That's an absolute lie.
Take up that argument with LIGO, because I got that information from researching LIGO, researching GPS. Where do they get these values from? How do they determine these values? And it's based on hypothetical reference models. Look up geoid in the dictionary. Look up Wikipedia. I'm not lying.
Yes, you are lying. You're misrepresenting and lying about it.
What am I misrepresenting, Blue?
Those elevation measurements are not based on a geoid, only in the sense that the benchmark elevation is based on that. But the rest of the elevations are taken on site, not with reference to a
On site
geoid.
with what?
Huh?
On
I've
site
told
with
you,
what
either
tool?
I would say it was a theodolite or a GPS system, one of the two.
So either a theodolite, or is it theodolite? Sorry. Or GPS, or is it both?
One of the two, or both. I don't know. I wasn't there.
You don't know. You weren't there.
That's right.
Okay. So why are you telling me that the values that are on the as builds are what they are in reality on Earth, not on a reference model?
It is not a reference model. They're not making a model of anything. They are measuring elevations with respect to a benchmark.
This was planned out prior to it being built, right?
Well, yeah, it had to be.
They had to set up all these measures prior to starting.
They had to set those. They had to figure out what the elevations needed to be in order to make that pad straight.
They went in with a plan, not just an idea, right? So they planned this.
Of course.
Meticulously planned.
Of course.
How
you don't
they are going to create.
You don't think they accidentally did that?
A straight line on a curved reference. How are you going to do
that? Not a
reference.
Not a curved reference. Not a curved reference. Mobius, I don't think
not
you know
a curved reference.
I really don't think you need to continue with this.
So you're saying that it's not a reference?
My God.
You went from saying it's not a hypothetical reference to now it's not even a reference? You sure you want to stick with that, Blue?
You sure you want to stay here?
Stay where?
Here. And continue.
You invited me here because you were afraid to go anywhere else.
I'm not afraid to go anywhere, Mobius.
Well,
I was
here.
at Bill's place.
If you want to kick me out, you can kick me out. That's up to you.
I know that's what you'd like, but I'm not going to do it.
Then I'm not saying I want to leave.
I think that's what you're trying.
I'll tell you.
I think that's what you've been trying to do is trigger me all along, and it's not going to work.
Oh, jeez.
Maybe you've probably figured that out by now.
I think you're pretty sensitive, and
yeah, they had to. Yeah, the guys at LIGO had the guys at LIGO absolutely had to figure out what the elevations needed to be in order to account for the curvature of our Earth.
And how do you think that they started with that whole process? Do you think that they assumed it was flat?
No. What do you mean? Assume it was flat. You know the Earth is curved. We know the Earth is curved. It's not a question.
I know it's got lots of curves. It's beautiful.
It's not a question. We know it has a curvature to it, and if we're going to use elevations,
it's got lots of curvature to it.
If we're going to use elevations, we're going to have to account for that over 2.5 miles.
Yeah, and that elevation is based on a vertical change from a horizontal reference.
No, it is not.
Look at, you just showed me a bunch of pictures and stuff that shows that that's what elevation is.
Well, just a moment.
God, Blue.
Just
it's like you're arguing with me for the sake of arguing. It's like
the elevation.
Do you even know what you're talking about anymore?
What are you trying to do? I do not know what you're trying to get to, Mobius. I have no idea. Elevation is defined as points of equal gravitational potential. Points that are equally an equal distance in essence, an equal distance away from the center of the Earth. That's what elevation is. It will deviate from a horizontal tangent at any point. Yes, it does that.
You said it's equal. Now you're saying it's deviating?
Say what?
I think you need to take a break.
No, I think you don't seem to understand anything much, Mobius. I'm being very
I
clear.
can't understand gibberish.
I'm being very clear.
You're saying that it's equal
Elevations,
potential, equal distance from the center of something,
yes,
and then you say
and
that
they
it
are.
deviates from horizontal.
And it deviates from a horizontal, from a tangent, which I define as, from a horizontal, which I define as a tangent at any point. If you take the start, take any point you like, and make a tangent line at that point, and level deviates from it. The further away you go, the more it deviates. And that deviation is about 8 inches per mile squared. And when you take the LIGO elevation data and correct it for 8 inches per mile squared, you get a perfectly straight line. I've been showing that for hours now. Now, that's what was done. You can bitch about it all you want to, but that's what happened. And the fact of the matter is that tube is known to be straight. Now, the only thing you've got is to say, well, maybe they did it with adjusters.
So the tube is straight, but they didn't use a horizontal reference to make sure that it was straight, right? Because it's sloping. So they used a slope to go off from that slope to make it have different elevations.
Yeah.
So that it's not an even elevation.
Yeah, the elevations do not plot a straight line.
Well, why didn't they just build it horizontal?
I can't answer why they picked the point they picked for a tangent plane. I don't know.
I mean,
why.
you asked me earlier why they went through all this trouble. I mean, how are you expecting me to answer that?
What was your question?
Just now?
Yeah.
I said, why didn't they build it horizontal?
Well, if you take a look at the elevations at Hanford, for instance, that might give you a clue. If you take a look at how the ground, the not where they did the work, but the ground around it, that might be a clue for you.
What's that?
That's the way the terrain slopes. Same at Livingston. Look at
The
Livingston.
terrain slopes?
Look at Livingston. Yes, it does. Look at Livingston. The terrain along that one arm that's almost level, not quite. There's one of them that's almost level, but that terrain is level all the way across there. But
Well,
when you
it's
go
just
to
4
the
feet.
other, when you go to the other arm, the terrain drops away pretty significantly.
Yeah, I mean it's just a 4 foot difference, right?
Yeah, so it's a 4 foot elevation change. Yes.
They're saying they don't have 4 feet of dirt. I'm just asking, like it just doesn't seem like why go through all that crazy mathematical computations to make sure that this thing, why not just build it horizontal? Just it seems like it
Because
would
the
save a
terrain
whole
was
lot.
Because the terrain was sloping.
But now they're using a horizontal to determine how much slope to drop it,
The terrain was
so that
sloping.
they can drop it even further from level, even though level
No,
is supposedly below horizontal.
it's actually higher in the center.
What? It's higher in the center?
Yeah.
Higher than what?
Well, I'm sorry. The elevations are actually higher on each end than they are in the center.
According to this thing that you got up on the screen, all the elevations are higher than the one at 13,000 feet. 2.5 miles away from the vertex. So what do you mean it's higher in the center?
What I mean is there's a 1 foot deviation at the center point of these tubes from a straight line. It's about 1 foot.
The lowest elevation in this thing, the lowest elevation in this thing is at 13,000 feet.
Yeah. Slopes up to 533, and from there, the next arm slopes on up to 538.
So that one, even that one's not horizontal?
No, it's not.
Neither of them are horizontal?
Neither one of them.
Well, why do you suppose they did that?
How many
especially when
times?
the
Okay, get your
is it
pencil
because
out
of the
and
mirrors?
get your pencil out, and we'll write it down again.
Is it because of the mirrors?
That was the way the terrain laid out.
I mean, it's a complex system
Yeah.
of pendulum mirrors within that
Mm-hmm.
thing, right? I mean, there's at least 6 pendulum
Okay.
systems, right? There's
It, it doesn't matter
one at
if
the
it,
end, one at the mid station, and one at the center, the splitter, and then at the other mid station, and then at the other end. So there's, well, not 6, 5, but then you've got the accumulator or whatever they call it, the detector, and then you've got the source. And the source, that's a whole series of mirrors all set up. What do you got here?
well, that's what drawn to scale up there at the top is what the LIGO the tube we've been looking at, the arm we've been looking at. That's what that looks like when you draw it, an elevation view of it to scale. Obviously, you can't see shit because it's only 4 feet in diameter, but it's 13,000 feet long. Now, I exploded both ends in the center point of it just to show you. On the left-hand end, I've drawn a plumb line, and the plumb line is at an angle of about 90.0175 degrees to the center line of that tube, or to the I dimensioned it to the wall, but the center line would be the same angle. If you draw and I've drawn a little box down there representing the mirror itself. If the mirror were actually, surface of the mirror were actually parallel to that plumb line, the red line is would be a line which is normal to or perpendicular to that plumb line, and it would intersect the tube about halfway down.
Well, I mean,
Instead,
we went over this earlier.
all they have to do is adjust the mirror slightly. A 0.0175 degree adjustment to bring the surface of the mirror normal to the center line of the tube, and that's what they've done. That's what they had to do. You've got a 4 foot elevation change. Yeah, you got to. You got a 4 foot elevation change. Huh?
You got any literature on that?
Yeah, I got it someplace.
All right.
I'm not going to look for it right now.
Not what they had to do, but what they did do.
No, that's what you have to do if you want it to work. If you don't want
I'm
the laser
saying, do you
hitting the
have
side
any
of the
literature
tube.
on what they did do, not what you say they have to do? Obviously, right here, you've got literature right in front of my face that what they had to do. I'm asking you if you have anything on what they actually did do.
Of course.
Oh, okay.
That's what it
I mean,
really looks like.
is that
Are you guys still trying to maintain the tubes are horizontal? Level?
well?
Are you still trying to maintain that?
I know that vertical, which is plumb, is
Uh-huh.
perpendicular to horizontal.
Yeah. Do you think the mirrors have to hang where the face of the mirror is plumb? Can you not envision a way that the mirror can be suspended so that it's got a 0.0175 degree tilt to it?
Wait, are we arguing about what we can envision possibilities, or are we talking
I'm
about
just asking you. I'm just asking
what
you.
is?
I'm just asking you. Do you think it's possible to have a mirror situated like that so that it's slightly tilted to adjust for the alignment?
Well, I mean, if it's sloping down
Have you
4
ever seen?
feet,
Have you ever seen? Yeah.
are you saying that the mirror is plumb?
No, it's not.
Okay, because it's sloping down, right? 4 feet it slopes. You said.
Yeah, it slopes 4 feet. It's suspended like a plumb bob, but that doesn't mean that the surface of the mirror has to be perpendicular or parallel with vertical, does it?
So because it's a
I mean, the sides of your
pendular mass.
the sides of your plumb bob are not parallel with that string above it, are they?
I'm sorry, what?
You got a plumb bob? You know what a plumb bob
Yeah.
is? Okay.
Yeah.
Are the sides? Is it?
I got a few different types.
Yeah. Does it look like a conical looking thing?
I actually saw one that looked like a horn hood ornament.
Yeah. Okay. Is it? But let's think about one that's like a conical looking one. You know, sort of a standard one. One of those you can buy next to the.
Yeah, like the standard brass ones.
Yeah. Standard brass ones. Are the sides of that thing parallel with the line it's hanging from?
Didn't you say it's conical?
Yeah.
Yeah. So
obviously not parallel, right?
Statement.
So
Yeah.
a pendulous.
Are you saying that those?
So
are
the
you saying that
side,
those
so the
mirrors are
sides of
conical?
so the sides of a pendulous mass don't necessarily have to be parallel to the suspension system, do they?
Well, if it's hitting a laser and bouncing a laser back, it's got to be perfectly perpendicular to that laser.
That's all.
Yeah.
That's all. So it'd be quite easy to adjust the mirror to be perpendicular to the laser, right? Obviously.
Easy?
Yeah.
I don't know, because in their literature, they say that the final alignment wasn't based on the theoretical alignment. They had to like do it differently.
Mm-hmm. Yeah, they actually use the laser itself.
Yeah. And it's just weird that they set it up according to the theoretical alignment and it wasn't right. But, it's just what their literature says. That, I mean, this is their documents, not like their high school handout pamphlets. Their actual white paper type shit.
Yep. All right, we'll go back to that. It would appear to me that those guys working for those little tiny companies like Chicago Bridge and Iron went to a hell of a lot of trouble to put a big curve elevation wise in those pads for no good damn reason. I can't think of why they would have done that. Certainly would have been a lot easier just to pour it level, wouldn't it?
Are you saying that I'm saying that it's curved?
No,
is that what you're saying?
No, I'm saying the
that would be
data.
stupid.
Elevation data clearly shows it's curved, regardless of what you say.
Right. I just want to make sure that you're not trying to say that I'm saying that it's curved.
No, I'm just saying that the elevation data itself shows it's curved, and it
well,
appears,
the elevation data was based on a hypothetical reference
and
model,
it's not,
so obviously
it's not,
it's
and
gonna...
that's a lie, and I'm
no,
not going to listen to it.
it's not a lie.
Yeah, it is a lie.
It's not a lie.
It is an outright misrepresentation and a lie. That
Prove
elevation data is not based on anything theoretical. Those are measurements made in the field.
Prove it.
I don't think I need to prove it.
I know you don't.
I have
but
no
you're going to
reason
sit there
to
and
want
say
to.
that you're right, regardless.
You have no proof that I'm wrong.
I have proof that it's based on a hypothetical reference model.
No, you don't.
All the literature says that.
All you've got is a benchmark.
All the literature says that.
Okay, put it up on the screen. I'm ready. Show it to me.
Let me open up another window. I'll pull up.
Oh, I'm sure I'm sure if you're talking about the way the pad has to pad elevations have to be established. Yes, that's based on the curvature of the Earth. Yes.
Based on the curvature of the Earth.
That's based on the known curvature of the Earth. Absolutely, it is. No doubt about that. But those
you mean a hypothetical reference geoid, right?
No, I'm talking about the curvature of the Earth. The rate of curvature of the Earth. 8 inches per mile squared. That
you mean
curvature.
The difference from horizontal?
That curvature. 8 inches per mile squared.
The difference from horizontal.
Yeah, that's drop from horizontal, but it applies also. It.
Well, in some cases, it's a drop from horizontal, and in some cases, it's a rise from horizontal,
No,
right?
no,
Yeah, that's
no,
elevation. Elevation
no.
goes both ways, up and down. Let's see.
While you look for that, I'll be back in a second.
Oh, hold on a second. If you're taking a break, I need a break. Are you taking a break? I think he took a break. I need a restroom break.
Okay, what you got?
All right, you back?
Yep.
I had to step away to
What you got?
get a green tea. You ever drink green tea?
Huh?
Hmm?
Green tea?
Green tea, yeah.
Yeah.
It's supposed to be naturally fat burning, I guess. Good for you.
Got introduced to that stuff in China back in the 80s.
Yeah, it's crazy. All the stuff they're coming out with now is, it's been around for a long time, but getting popular and stuff like matcha tea.
Yeah,
That's
that's
another
all.
popular one.
All the Chinese drink is that green stuff. It's pretty good.
Hmm. I like it. So where were we? What were we doing? I was looking for something that said,
If you're going to show me something that says they took Earth curvature into account, don't bother. I agree. Yes, they did. If that's where you're going with it,
here
of
if
course it
if you
says that.
type in Google, if you type in Google, anybody can do this. The dictionary,
Mm-hmm.
Oxford Languages,
Yep.
geoid, the hypothetical shape of the Earth. coinciding with mean sea level and its imagined extension under or over, in parentheses, land areas.
That's right.
I'm not disagreeing with that. Why do you argue with me when that's what I say and you say that's wrong, and now you're saying that's right?
Well, you're
I don't
quoting
get it.
something. You're quoting something that is correct,
I
Mobius.
read it directly.
But you're saying these elevations, that all of these elevations taken are directly
based on the
based.
geoid.
The absolute value is based on that geoid. Yes.
Which is a hypothetical shape.
But Mobius, one more time. Let's see if you can follow me this time.
And
Whatever
its
that
imagined
we
extension.
okay. Let's take that away. What if we take it away completely?
Take what away? Take away the definition of geoid?
You want to listen for a second, and I'll tell you.
Okay,
I think 529 point whatever it is was the low end. I know it was. All right. Let's subtract that geoid value at that point from all the rest of these elevations. How will that change this picture?
Wait, what?
Eliminate the geoid, the actual absolute value of the geoid, which is 529 point whatever, at that low end. Eliminate that totally. Just call that 0. Subtract that exact number from every one of the other elevations, and how will that change this picture?
Well, you'll just take the same exact diagram that you got and move it down vertically to where that 533.5 or whatever you said is at 0, and then it'd be the same exact thing.
Yeah. So what did the geoid do? It only established 1 point, one reference point, and they tell you in the drawings what they use for the project datum. You want me to find that for you?
Are you talking about the 3 benchmarks that were off-site?
No.
Or are you talking about the ones that they use on the those right there?
Wait a minute.
No, you just had it. The ones you circled in red?
No, that's not what I'm talking about. I'm talking about the
NAVD 88 benchmarks.
Get back there in a second. You see that?
Mm-hmm.
Vertex 0 elevation. This is the project datum, 537.29 feet.
Yeah.
That's the project datum. Beyond that one number, that one time, there are no more references to the geoid made in any of these measurements. Just that absolute datum point. That's all.
Why would they need to keep referencing it at every point along?
They don't.
It's built into the design. It's
What do you
built
mean?
into it.
What do you mean they have to keep referencing? What are you talking about?
You're saying that it only references it once.
That's consistent throughout the project, everywhere. That's the project datum.
I know they're still using the same reference model.
It's just an elevation, Mobius. It's 1 point. It's 1 point.
Dude, the computation that's involved in the programming itself is based on a reference model, on a Cartesian coordinate system, XYZ coordinate system with the presupposed center. Okay? I don't know what you're arguing against.
I don't know what you're arguing against. I have no idea. You keep saying that these measured elevations are based on a model. No, they're measured elevations.
Your diagram with the curving thing, that curve,
yeah,
that's a hypothetical curve based on that model. The arms can be straight.
Those are actual measured elevations.
Based on what?
Based on actual measurements.
Let's take this.
And yes, that curve.
533.5.
And yes, that curve.
At 0. Sorry.
Yeah. And yes, that curve was built into it. Yes, it had to be in order for it to end up straight.
Let me know when I can talk.
Okay, go ahead.
If we take it 0 point on the station feet, we've got 533.5 whatever. Let's say 5.5. If we build that into a model that's curving, then all those elevations would be off of that model.
Off of that one number, yes.
Right. So if the ground itself, if they leveled the ground and they used a horizontal reference, it would be straight. But they're using a curved reference, so the values that it shows will be curved.
That's ridiculous.
That's not, it's what you're showing me. It's
Absolutely
what's
ridiculous.
happening. Work it out, Blue. Just,
It's ridiculous. Your level of misunderstanding is astounding.
Great. That's not you working it out or explaining how I'm wrong.
I think I've done that about 15 times already. There's no real
may
point
think
in
you
going
have,
through it
but
again. I have.
I haven't heard anything that's substantial yet, except for I'm right because I'm right. I mean, that's the level of
Mobius, that's what you're doing.
How?
That's all you're doing.
I'm taking the information that's out there, which says that these elevation values are based on a hypothetical model. I'm taking that information and working out how that curve can be represented on this graph while still having a straight structure in reality. And the way that I do that is using basic first principles, geometric fundamentals, and knowing that an elevation drop or rise in vertical is from a horizontal plane of reference. It's perpendicular to that horizontal. You're telling me that if somebody goes out there, you're telling me that if somebody goes out there and uses whatever tool that they can muster to establish a horizontal, that dotted line that isn't the actual read. I'm talking about the horizontal. Whoever's establishing the horizontal frame of reference or reference plane, they're going to get a drop if they want to slope downward. They're going to get a rise if they want to slope upward. They're going to get a curve if they want to differentiate the values to represent a curve. People build things in real life. A driveway that slopes down and has curve to it. Those are things that are done in real life, in reality. Right? With a straight line elevation profile, you can see these things and they match reality. This right here that you've got on the screen, this curved thing, that's not how the thing is. If it's straight, it's not curving like that. So this curve is a representation of the hypothetical reference model that they use to come up with these values so that you can represent it as a curve on this graph. It doesn't mean shit, Blue.
Okay. All right, Mobius. And that's where I thought you would go with this. That's exactly what I thought you would do.
I'm
because
glad
you
were
have
right about something.
Because you really don't have any place else to go, do you? That's the only thing you can say. I understand.
All I've been
That's
saying.
okay.
That's all I've been saying.
That is okay.
Show me how I'm wrong.
I have shown you how you're wrong time and time again, Mobius. These are
Where
actually
have you shown me?
These are actual as-built elevations, and you're questioning them. Okay, that was the answer.
I'm not arguing with what's in black and white.
I'll tell you what we could have done.
I'm not disagreeing with what's in black and white.
Shut the fuck up for a second. We could have avoided the last 4 hours of bullshit.
Be right about what I'm disagreeing with.
We could have avoided this last 4 hours of bullshit if you would have just answered the question that I ask you time and time and time again, which is, do you contest the elevation data on the as-built drawings? And you weren't honest enough to do that.
What are you talking about? I answered you.
You would never tell me that you agreed or disagreed with those elevation points, those elevation
I told you
measurements.
I don't contest them. They're based on a hypothetical reference model. Of course they're going to represent the hypothetical reference model. I'm not contesting what's in black and white, Blue.
You're not saying are you honestly now going to say that you're not contesting those? While
I've
at the same time,
I've never contested
while
them.
at the
I made
same
a
time
video
saying,
about them.
while at the same time saying that it's
Jesus
based on a
Christ. I made a
hypothetical
video
model.
about it.
Are you saying that any of these pad elevations are actually just a model? That nobody
Is that
actually
what your
went
hard-on's
out.
about?
That
Do
actually
you really
that
think
nobody
that I'm
actually went out.
contesting
Nobody
in
actually
black and
went out
white?
there and measured those elevations. Is that what you're
Oh
saying?
my God. I didn't
Or
know
not?
that you were hyped up about something that is fabricated in your imagination. I never disagreed with anything that was in black and white.
Okay, fine. In that case, those elevations plot a curved line on a graph like this. But when you include curvature of the Earth, it is a straight line. That's the only point I've made. That's the only point I've tried to make.
When you include what curvature of the Earth? The ones represented by this graph?
Not the ones represented by this graph. Curvature was taken into account when the elevations were established. Yet it forms a straight line, and you can't deny
You mean
that.
the single benchmark?
Yeah, a single benchmark. That's all that's needed.
And you weren't there. You weren't there to determine how they measured these different elevation values.
I've told you several ways they could have been measured.
I know you've told me several ways they could have been. That's not what I said. I said you don't know because you weren't there how they did it exactly. Yeah, anybody can hypothesize which method they might have used.
Would they give different answers?
I don't know. Would they?
No, they don't.
So from a
No,
horizontal
they
reference, you're saying that wouldn't be different?
Get off the horizontal reference and
why do you need me to get off a horizontal?
Lose that argument. It doesn't work for you.
Why do you need me
We've
to
been
get
through
off
that
horizontal?
time and time again.
Why does this
It doesn't make any
conversation
difference.
require me to get off of the thing that my whole
Oh, don't
position
get all
rests
excited
on?
now. Don't get all triggered.
I'm just asking you why you need me to get off of
Don't
it.
get all triggered. Come on.
This isn't triggered.
Maybe we ought to go back and talk about driveways or something you got some experience in. I don't know.
This isn't
But
triggered, Blue.
this is yeah, you're clearly upset. I'm sorry about that, but the facts are the facts. That's the shape of the thing in terms of elevations.
If you think
but
this is upset,
the actual shape is straight.
you must get scared by bunny rabbits. I swear. You think this is upset?
You're clearly upset, Mobius. Come on, give me a break.
What's clear about it? I'm not upset. So why would you perceive me being upset?
Oh, just the tone of the in your voice and the way you're over talking me all the time. That's one good clue. But anyway,
First of all,
here these.
I don't know. Sorry, I was in the middle of
All right, go ahead.
saying something. You said I was over talking you. Yet, so like I said, I was going to say is I don't know if sometimes there's delay or anything like that, but I notice that you talk over me a lot too. So I'm not gonna nitpick and bicker about it. We can move on. Fair enough or no?
All right. Well, the fact of the matter is, still remains that those elevations are measured. Now they were established, without a doubt, by considering the curvature of the Earth. If you're going to try to eliminate that and make the pad straight, how would you do that without considering the curvature of the Earth? Clearly, that's a requirement, and to try to say otherwise is just stupid. Of course, they did. But
Well,
it can be confirmed. I'm not done yet. I'm still talking. But it can be confirmed by the as-built measurements of the elevations, and that is what those plot, that curve. And when you take into account Earth curvature, it forms a straight line. And what we know in addition to that is that the tube sitting on top of it is perfectly straight in free space. So that's the end of that. There's nothing else to say about it. Thanks for coming. I'm going to give you the last word, and then we're going to end this.
Oh. All right. Well, you disagree that the data on this graph here, the elevation values, are derived from or based on a hypothetical reference model. I contend that they are. You disagree. You say that a water level does not establish a horizontal plane of reference. I disagree. I think every example in history from the beginning of time would agree with me, um, or demonstrate that that's accurate. But you disagree. I don't know. I wanted to try to find some agreement between us, but I do, or I would appreciate uh, if you would refrain from saying stupid shit like I'm a chicken, would not come here to talk to you. I have no problem talking to you, Blue. I don't think that you're entirely a bad guy. I don't want besides the you know uh trivial colorful insults that you dish out all the time. Sometimes I think they're pretty funny, but really wrong and inappropriate a lot of times, but whatever. You're you. That's fine. Uh, thanks for having me over. I guess that's it. Not really much to say.
All right. I would love to be able to go back and shout out all the super chats, but I think I've probably lost them by now. If you're one of the very kind people that gave to the cause, so to speak, thank you so much. I really appreciate it. But I didn't want to interrupt what was going on just to go through that stuff. So I hope hopefully everybody will understand. And with that, I think it's time for everybody to take a break, and we'll see when we're going to do the next stream. Thanks again, Mobius. I'm going to end
Yep.
this thing at this point. Good night,
Thank
everybody.
you.